Hello, Professor Ashwin.
Hello, sir. Amir, sir. Good morning.
Good morning, everybody. Our session chair is here. Let's wait for 2 more minutes so that the other participants get joined, and then we'll begin the session. Good morning, Ranveer sir. We welcome you for the conference.
Viksham sir, can you hear me?
Yes, sir. Yes, sir.
Sir, what about the status of 158 paper?
Yes, sir. She joined, sir. Revati Durgam.
She has joined or she will join?
She joined, sir. She joined.
Joined, huh?
Revati Durgam. Her name is Revati Durgam.
Revati. Okay, right. Swati, madam?
Sir.
Madam, please start. I think all the session chair are present right now.
Okay.
Yes, Professor Dr. Ravindra is yet to come. Professor Ved Prakash Bharadwaj from UPS, he has joined the meeting.
Yes, sir. Yes, sir. I'll go on, sir.
Yeah, Professor Vipin Kumar also I have joined, I guess.
Vipin, yes, sir. Vipin,
Ah.
sir, has not joined, I guess, sir.
Vipin sir not joined, huh?
No, sir.
Yeah. Let me call him, madam. Let me call him. Just
Okay.
wait for a minute. Huh? Right.
Okay, sir. Okay.
Right. Swati madam.
Sir.
Our two section chairs already have joined the meeting. Dr. Ravinder from Thapar University, Patiala.
Okay.
And Dr. Ved Prakash Bharadwaj from University of Petroleum,
Petroleum and Energy Storage. Yes.
Yeah. And Professor Vipin Kumar, just now I have spoken with him. He is telling that he's joined within 30 seconds. So the moment he will join, then you can start the session by...
Okay, sir.
Yeah.
Done, sir. Done.
Great.
Morning, Swati ma'am.
Good morning, sir.
Sorry to join late because I have a schedule around 12:15.
No issues, sir. No issues, sir. It's okay, sir. No issues. Thank you so much.
We are waiting for the Vipin Kumar sir. The moment he will join, then we are going to start the session. Dear authors.
కండిషన్ ఉందంట 10% ఇన్ హౌస్ చేస్తారని దానివల్ల సెకండ్ టైం రూట్ వెళ్ళిపోయింది మళ్ళీ కంటిన్యూ మనకు 20% 30% కావాలి. చెప్పడానికి ఇదంతా
Good morning, everybody. I guess all our session chairs are here.
Yeah, go ahead, please. All clear.
Okay. A very good morning to one and all. I'm Swati Gaurachu from CSC department. Would like to welcome all the keynote speakers, session chairs, authors, and participants to the second day of International Conference on Artificial Intelligence and Data Science 2022. We are glad to have the session chairs for the fifth session, Dr. Ravinder Kumar from Thapar Institute of Engineering and Technology, Patiala, Dr. Ved Prakash Bharadwaj from University of Petroleum and Energy Studies, Dehradun, India, and Professor Vipin Kumar from KIET UP. We welcome you all, sir. Dear authors, our session is about to begin. Each author will be given 10 minutes of time and 3 minutes for queries. We request you to wind up your presentation in stipulated time. Firstly, I would like to call upon paper ID 170, Rakesh Kumar Verma.
Ma'am, this is 158 paper ID. One change is there.
Oh, okay, yes, sir. Okay, I would like to call upon 158, paper ID 158, Revati.
Yes, Revati.
Good morning.
Good morning, Revati ma'am. Can you share your screen, please?
Yeah.
You can start your presentation, madam. Huh? Right.
Actually, I'm getting post-disabled participant screen sharing. Can you?
Yeah, I'll make you host. Just wait. You can share now. I have made you co-host.
Okay, so thank you.
All right.
Sir, can you see my screen?
Yes, Revati.
Yeah, thank you.
Please share your slideshow.
Full screen. There's opt. Yeah, great. Now perfect.
Yeah, okay, so thank you. A very good morning to all. I'm Revati. Today I'm here to present my paper, A Machine Learning Approach to Detect Brain Stroke. In today's study, machine learning is used to tackle many real-world issues. So using the same, I'm here to detect the brain stroke. So here, machine learning is used in many real-time approaches in order to reduce the dimensionality. So reducing dimensionality improves the accuracy and also it improves the prediction rate. So here we are using a machine learning approach to detect the brain stroke. So the main approach in my paper is information gain based feature importance is used to predict the brain stroke. This technique considers information gain metric that makes use of entropy. So here entropy is used in as a method which is used to measure the uncertainty in group of observations. So when the machine is trained, we need to observe in different groups so that the feature selection can be easily performed using this information gain based feature importance. So here the main keynote is we are using the entropy. Entropy is used to select the features in an effective manner. So this improves the efficiency of detecting the brain stroke. So according to the survey, it is observed that prediction models work at their best only when the training data has an adequate quality. So that means if the data set that used does not have the quality, then the performance of the prediction will be reduced. So in order to improve my performance rate, here I'm using the particular method called entropy in information gain based feature importance. So there are many supervised techniques. So this is one of the technique that have been used to detect the brain stroke, which will makes more efficiency in detecting the brain stroke. So here in my particular paper, we have used three main observations. That is analysis of BMI, effect of glucose level, effect of age. These are the three groups where we have performed this entropy. So here analysis of BMI is nothing but body mass index, and next group of observation is effect of glucose level in a particular person body and effect of age. So these are the main three considerations that we tend to take the data set from these three observations. So according to the analysis and using of entropy in my paper, I have found that the effect of age gives us more adequate results rather than considering BMI and effective glucose level. So performance on effect of age gives us the prediction of brain stroke very adequately. So after finding observations using entropy, decision is chosen for finding the best features. The IGFI algorithm, after training by different machine learning classifiers, like I have used classifier like XGBoost, Random Forest, etc., for training my particular data. So these particular all are being used on three particular data sets, and again from that particular three data sets, I have chosen the data set of effect of age. So this gives more impact on brain stroke prediction positively. While training the data only for that particular selected features, this also reduces the search space, saving time and also memory resources. So the analysis of this particular algorithm has an iterative process that computes importance of each feature, and also it chooses the best features that helps in prediction of brain stroke. So gain metrics that uses of entropy is used to measure the uncertainty in group of observations. So that is the main keynote of my paper. So this is basically the proposed frame of brain stroke detection. So here we have taken the brain stroke dataset. Here the brain stroke dataset, after training, we have taken the dataset of age of the people, and there the data is being splitted, IGF algorithms and ML algorithms. Then the brain detection model is used. So from this particular train model, we can say that the person can be affected with stroke or without stroke. So this is the basic algorithm of my proposed algorithm, IGFI. And after training different models on the particular dataset, we have seen that classifier random forest has the highest accuracy rate in predicting the brain stroke using the age of the person data set. And also next comes the XGBoost, which gives a good performance in predicting the stroke of by age of the people. So these are basic result analysis that have been used. So you can see here the three different analysis: effect of BMI on brain stroke, effect of age on the brain stroke. So coming to the conclusion, IGFI algorithm is capable of impacting the brain stroke prediction models positively, as it is using the keynote feature called entropy. So here it can be used in clinical decision support systems in healthcare. And coming to the future scope, we can build hybrid prediction models for improving the performance more. Thank you, sir. Thank you, ma'am.
Okay,
Okay,
Revati,
Revati.
I have one question regarding this.
Yes, sir.
Can you tell me what is the source of your data set?
A benchmark data sets only, sir. I have used benchmark data sets.
Okay, can you tell me which benchmark with some specific organization or some name of that data set which you used? Because we have a lot number of data sets for the brain strokes. Some
Sorry, sir.
specific. Do you have some specific data set?
Data set? I am using brainstroke data set, sir.
Yeah, there should be some name to the data set, right, Revati?
In Kaggle, ma'am. So in my
Okay, from the Kaggle.
In my
You are using from the Kaggle.
Yes, sir.
Okay, that repository is belong to the Kaggle. Okay, can you tell me the size of data set? How many number of features in your data set?
Features I have taken 15, sir.
No. How many count of pictures? How many images you have in your data sets?
Not images, ma'am. I have taken the age factor.
No, in the database. Can you show some sample database that you have at least?
No, ma'am.
Okay. Any other sessions here would like to ask a question?
Yeah, one question from my side, for Revati. You have taken some data set, that is fine. And further, have you compared your work with some existing algorithm? Can you please share?
I have compared using different classifiers, sir, not using different algorithms.
So can you please come on that particular graph that where you have shown the comparison? That how much means what we can say the performance is increased in your case or lacking in performance, whatever the things which is going with your paper. No? Can you please show that graph again?
Okay.
Revati, I hope you have to noted down all the suggestions given by the session chairs, right? And
Okay,
you have to
yes, sir.
you
Yes,
have
sir.
to and you have to look at where exactly you are lagging. Okay, na?
Okay.
So that it will give you idea in future whenever you are going to present a paper, what type of questions generally ask and how you have to defend them. Huh?
Okay, sir.
Swati ma'am.
Sir.
Yeah, we can call the next participant because 10
Okay.
o'clock we have a keynote.
Okay, sir.
Right?
Okay.
So we are running short of time.
Yeah. May I call upon paper ID 119, Punit Gupta?
I think 119 has not joined yet. We can call
Okay,
next 195. Yeah.
I'll go with 195, Pankaj Sharma.
Pankaj Sharma, can you hear?
Pankaj Sharma.
Good morning, sir. Sir, I'm joining.
Yeah.
Okay, Pankaj Sharma. Can you please share your screen, presentation screen?
Is it
Yes, it is visible.
visible?
Keep it in full screen.
Pankaj, make it in full screen. Downside, there's one option is there where you can see 70%. Yeah. From beginning. Yeah, from beginning. Topmost left hand side, from beginning. Top you can see one option is there from beginning. You have to click there.
Sir, I'm not able to see that option, sir.
Downside also where you can see 70% is written there. Right hand side mein down bottom. Zoom 70%. There's a one cup button is there. You can press that also. Okay, no issue. You can start presentation. No issue.
respected dignitaries, teachers, and my dear colleagues. My name is Pankaj Sharma. I am from Jammu and Kashmir, Ph.D. part-time candidate of JP University of Information Technology, Solan. And topic of my presentation in first international conference on artificial intelligence and data science is an efficient mobility aware scheduling algorithm in fog computing environment. These all are the outline I've discussed in my presentation. So in present scenario, world is moving towards smart devices, particularly after the introduction of IoT devices. Fog computing basically is an expansion or extension of cloud computing towards the edges. Fog computing in real world perspective utilizes the and user client and neighbor as devices to perform computation and communication. Basically, in fog computing, for computing, we have to advantage of location awareness, and we have to work in low latency. In cloud computing, there is a problem of
PPT is not moving.
Yes, sir. So basically, the issue in the fog computing is the reliability of fog node. Sir, yes, sir. Sir, not clearly audible, sir.
PPT is not working. PPT is not moving.
I'm
Slide
on
is
the introduction. I'm on the introduction slide, sir.
at my part it's not visible.
Sir, is it visible?
Okay.
Visible, sir, now?
No, sir. Is it visible to other? Please acknowledge.
It's visible but not scrolled. Only first slide is visible.
Only first slide is visible. Yes, sir. Yes, sir.
Hold on to second slide. Mr. Pankaj.
Pankaj Sharma, once you just close your this sharing the screen option and redo it, okay?
Sure, ma'am. Sure, ma'am. Sure, ma'am.
See, if you are sharing full screen, are you sharing only PPT screen or entire screen are you sharing?
Ma'am, full screen, ma'am.
Yeah.
Okay, now you just press from the beginning option.
Left hand side, yeah, left hand. He has closed the PPT, I guess.
Yes. Actually, those slides, I think he's not sharing the full screen, sir. He's just sharing only PPT screen.
Yes.
That window he is sharing.
Pankaj, you have to click on the share, then you have to share the entire screen.
Okay.
Otherwise, you just share the full screen window. That is also fine, okay?
Is it visible now, ma'am?
Yeah, PPT is visible. Now you just go to slideshow from the beginning.
Yeah,
that's done.
perfect.
Now you go on, okay? Yes. Please carry on, Pankaj.
Fog computing is still facing challenges, particularly when dealing with the IoT devices, mobile devices. Existing fog computing paradigm still faces the issue of seamless accessibility of fog services to the mobile node. Fog computing still also tackling an issue of mobility when tasks originate from mobile ubiquitous application in which the data source are moving object. So there is a need to propose a new framework. So in this work, I have proposed a new novel mobility aware scheduling policy. In this framework, I have to first predict the location of the mobile devices. After that, map the incoming request to that particular devices. In this framework, middleware play a key role. Middleware play a key role and interface between the IoT devices and fog devices, and also predict the location of the mobile devices. In this diagram, in this framework, a set of IoT devices combined to form a tire. Tire consists of an n number of IoT devices. So in the middleware layer, there is a one particular fog node who take care of a particular tire. So after that, if any request, a task is originate from a task is originate from allocation of fog node. So mapper map the requirement of the user to a particular fog node depend upon the processing capability of that particular fog node. So physical availability is predicted based on the movement type of the mobile devices. Movement type is predicted based on the movement direction of mobile devices to the fog node. There are two types of movement type, namely movement towards fog node and movement apart from fog node. Movement type is predicted based on the hidden Markov model. The location of the mobile devices are found by the GPS, which is assumed to be a part of the fog layer. The distance between the mobile device and fog node is found by using Haversine formula. So in this diagram, P1 is the location known by the fog node and P2 is the new location, and R is the radius, arc radius from particular fog node. So I have to find the distance D with the help of Haversine formula. So hidden Markov model is also used to predict the current location of the mobile devices. There is a conditional dependency between variable two location of the mobile device, and the previous next location is depend only on the previous value of the location. So this formula is derived from the previous. This function is derived from the previous diagram with the help of trigonometric function D equal to R sine inverse D upon 2 R square root 4R derived from the previous using trigonometric formula. So mobility can be found with the help of this equation, P1 minus P2 upon time taken to reach out from P1 to P2, and physical availability fog node equals to fog node coverage area minus P2 upon mobility, and physical availability factor is also found from physical availability upon tire resistant time. So these state of the fog node is also taken into consideration before allocating a request to particular node. So we have to take care of number of requests already running by the particular fog node, number of requests in queue, and request sum of remaining process and time of running job. So proposed work is implemented using Java language on iFog sim simulator. So I have to find the effect of physical availability factor on execution time. In this graph, if this graph depicts the effect of physical availability factor on execution time. If the physical availability factor is more, then it take less time. If we increases, if the execution time increases with the execution time decreases with the increase in the physical availability factor. So I have also calculate the QoS value of our framework, quality of service parameter of our framework. So this work basically proposes scheduling policy for predicting the mobile node location and predicting the physical location of the mobile devices, and also allocate the user request to a particular efficient fog node. The proposed algorithm is to improve the various QoS parameter and also work on the bandwidth and also appraise the allocation policy. The physical availability prediction using the movement type, movement pattern, and movement direction of the fog node. The experiment result have depicted the consequence of physical availability on execution time, usability, reliability, response time, and all that. We have obtained the average overhead of the proposed framework is 76.6%, which is equivalent to the cost effectiveness of 73.4%. So it's all from my side, sir.
Thank you, Pankaj Sharma. I request session chairs to please go on with the queries.
Hello, Pankaj.
Yes, sir. Yes, sir.
This side. I have one question. You were talking about the HMM. Can you go on the figure number 2?
Figure number 2. Yes, sir. Yes, sir.
Is it any relation of the HMM with this?
Yes, sir. Sir, P1, P2, the random variable P1 represent the hidden state at time t, and the random variable P2 correspond with the location visited at time t. So P1 and P2 is 2 variable basically.
Okay. Actually, you are talking about the HMM. Hidden marker.
G, sir. G, sir.
About HMM, you need to some seed values, initial values.
G, sir.
According to this figure, you are taking P1 and P2. Both are the random values. If we are taking the random values for as a seed in the HMM, that may be some problem in further calculations. Is it so?
Basically, sir.
In values, we have
yes,
some initial protocols taking those values. Have you done something on that?
Sir, basically in a 3 coordinate system, P1 equal to x1, y1, z1, x equal to cos theta, sin theta. I have found the value from there, sir.
Okay, fine. Thank you. Thank you.
Yes, sir.
Any more queries? Participants, anybody would like to ask any questions? Okay, thank you, Pankaj. You can stop sharing your screen.
Thank you, ma'am. Thank you, sir. Thank you, sir. Thank you, ma'am. Thank you, ma'am.
Now I request paper ID 142, Gaurish Garg. Can you hear me?
Gaurish Garg. Yeah.
Yes, ma'am. Yes, sir.
Yeah.
Please share your screen.
Is my screen visible?
Yes. Full screen, please.
Yes. So, very good morning to all. I am Gaurish Garg from Thapar Institute. And in the work I propose is assistive technology for architects that will aid the architects in designing their product according to the needs of the people affected with visual impairments. The architects will be able to see the digital edition of the 3D model from the perspective of the visually impaired so that they can modify the model as per the needs of the visually impaired. The proposed model aims to provide an assistive technology for architects through which they can view the digital edition of the 3D models in the real world from the perspective of visually impaired. That includes simulation of cataract, glaucoma, and macular degeneration. That is the 3D model which is made by the architects will be passed into a software, and then that will be augmented in the real world space, which can be then viewed from the perspective of visually impaired. After the architect views the model from the perspective of visually impaired, he or she can customize it according to the needs. So the existing works in this field are a virtual reality helmet, which uses a practical virtual environment using virtual reality to simulate the visually impaired. Another existing device is variable see-through display, which generates a stereoscopic illustration of how the visually impaired see the world. Imagine Z800 3D visor is a virtual reality helmet through which healthy sighted can practice visual impairments like scotoma, cataract, etc. Another one is XRI, which simulates the refractive error and cornea diseases. So coming to the methodology, we talk about two kinds of apps, like both have the same features and functionality. Just the difference is that the one app is made for the phone, which uses the touch controls, and the other app is made for the augmented reality cardboard. Augmented reality cardboard is like a Google Cardboard with a hole for camera, in which we can put a phone and create a video see-through display. So I'll be majorly focusing on the app which is made for the augmented reality cardboard. So first of all, the architect creates the digital edition of their model using software like Blender, Revit, etc., and uploads it to a server. And then it generates a QR code which contains the link of the server. Now, the architect opens our app, scans the QR code, and the object pointed to by the QR code is augmented in real world space. Is augmented in real world space using augmented reality. After the object is augmented in real world space, then the architect can visualize the object from the perspective of visually impaired by just speaking the name of the visual impairment. So the tools technology used for this is, like for cataract simulation, we used visual blurring and Unity particle system to simulate cloudiness. For glaucoma and macular degeneration, we used the vignette images and reverse vignette images as canvas overlay. So coming to the results, like we can see here, the first picture shows the app created for the simulation of cataract in the phone, and the second picture shows simulation of cataract in the augmented reality cardboard. Here, the person is able to view the virtual object in a real world space from the perspective of cataract in the first part. The second part, the person is able to view the virtual object in real world space from the perspective of glaucoma. And in the third part, the person is able to view the virtual object in the real world space from the perspective of macular degeneration. And it will be more clear when I show this. Here it is listening. The moment I speak glaucoma, the glaucoma is simulated, macular degeneration simulated, and the person is able to view the virtual object from the perspective of glaucoma and macular degeneration. So thank you for listening.
Thank you, Gaurish. I request session chairs to please go on with the queries.
Hello. Hello.
Yes, Sai Krishna. Yes, Sai Krishna.
Good morning, sir. If data is unlimited, how we will deal with that, sir? Unlimited in the sense if you have more data.
Data, we don't, it's not like a machine learning approach, like we require some data set. We just need to upload an object to a server, and then we can view that from the perspective of the visually impaired.
Okay, okay.
Any more queries?
No question from my side.
Okay, sir. Any other participants
No
would like to
question. No
ask
question.
questions? Okay, sir. Okay, sir.
Madam, I have a small question.
Yes, sir. Please go on, sir.
Sir, question to author. Sir, what are the software tools that you have used and what is the novelty in it?
It's the software tools I have used is Unity game engine for developing the application and Vuforia SDK for augmented reality. For QR code scanning through the game app, the Zing library is used. And the novelty is that existing methods are like object is when object is sent to developer and then it is included in game files, which is a long process. Like the developer has to physically include the object in game files. But in this, the object is directly brought to the app by scanning the QR code. No need of including the object in game files, and simulation of visual impairments like glaucoma, cataract, and macular degeneration be performed.
Any other queries? Okay, Gaurish, that was really a fantastic presentation. Thank you. You can stop sharing your screen. I request all the authors and participants to stay back. And firstly, I would like to thank all the session chairs for gracing the session. Now, we have a keynote speech on IT's response to the COVID-19 pandemic solutions, challenges, and suggestions. I'm very much delighted to introduce our third keynote speaker, Dr. Justin Zhang, to the conference. Sir is the faculty member in Coggin College of Business at University of North Florida. He was previously an associate professor of MIS at State University of Newark, Pittsburgh. He received his Ph.D. in business administration with a concentration on management science and information systems from Pennsylvania State University. His research interests include economics of information systems, knowledge management, electronic business process management, information security, and social networking. He's the editor-in-chief of the Journal of Global Information Management and ABET Program Evaluator and an IEEE senior member. He has published his papers in very much reputed journals such as Journal of Knowledge Management, IEEE Transactions on Engineering Management, Expert Systems and Applications, and many other leading journals. We are very much delighted to have you here, sir. I request sir to please take over the session.
Okay, thank you very much. Let me share my slides. Thank you very much for the introduction, and I also want to thank the conference committee for inviting me to make this speech. It's an honor to be here to share this findings about the IT solutions, challenges, and suggestions for fighting the COVID-19 pandemic. So this is the agenda for my talk. So I'm going to first talk a little bit about the background of this talk. Then I'll summarize the existing IT solutions for tackling the pandemic. And then I will talk about the challenges and solutions. Finally, I will conclude this speech. So we know the COVID-19 pandemic has caused an immense impact on almost everything, including hospital systems, businesses, schools, and the economy. Telemedicine, telework, and online education has become essential to help the society slow down the spread of the virus. And at the same time, the pandemic has generated a rapid demand for effort to use innovative technologies to cope with damage from the pandemic on our life. The pandemic has also raised opportunities to advance technology-based solutions and also provided a rare opportunity for us to study the research and practice of technology, such as information management, work practices such as work from home, and nowadays we call it work from anywhere, and the design and use of technologies. The quick transition to telehealth, telework, and online education in response to the coronavirus threat is a reminder that digital technology brings many benefits and can play an essential role in managing and reducing the risks caused by the lockdown during the pandemic and even after the pandemic.
Sam will be in conference.
So it is well known that IS and IT play an important role in healthcare, clinical decision support, emergency crisis response and risk management. So we know many IT/IS professionals are working in various ways to help fight the pandemic. So including developing products to combat the virus, tracking and predicting its spread, and protecting hospitals from cyber attacks. Information technology scholars should contribute to this global effort to fight the pandemic and maybe also future crises by leveraging our previous experience and knowledge by responding to the crisis, decision-making, remote working, managing virtual teams, analyzing large data sets, etc. So the pandemic has also some implications for the design, development, and use of information systems and technologies. So IS and IT researchers and practitioners can help conduct the analysis of the pandemic data and engage in potential emerging research topics. So for instance, facilitating work while social distancing, contactless commerce, face recognition, the pandemic apps, crowdsourcing, data donation, tracking cases, robotics, etc. So essentially, there's some kind of initiatives we can all be part of it, such as redesigning the public health system from reactive to proactive through the use of real-time surveillance systems and contact tracing tools. And second, transforming organizations through enhancing crisis-driven agility and reducing crisis-reviewed fragility. And next, empowering individuals and communities through adapting, coping, and stemming the infodemic. So various scholars and practitioners, they have come up with some solutions. So I want to give a brief summary of the existing solutions in this context. So the pandemic has revealed the urgent need to redesign the public health system. So I just mentioned from reactive to proactive, and develop innovation systems to provide real-time information for proactive decision-making at the local, state, and national levels of public health system. So we know COVID-19 is different from chronic diseases as it is highly contagious. It can pass from people to people and has a high mortality rate. So in addition, COVID-19 is a new disease, so we don't have a lot of scientific understanding of the virus that causes it. So we don't even know many of the medical responses and actions So that's why the impact of COVID-19 on people and society
కాన్ఫరెన్స్
some immense impact to the society. So in response to the threat and risks, so we have seen many existing IT solutions. So for instance, machine learning, deep learning, and other artificial intelligence technologies have been widely used in analyzing epidemic situations. And other like image recognition, deep learning algorithms can also be used for early detection and diagnosis of the infection. More rapid drug discovery for developing new treatments can also be facilitated by using AI-based algorithms. So a few companies also repurposed existing AI systems that were initially designed for other areas to assist in social distancing enforcement and contact tracing. So AI and all kinds of AI-based technologies can be used to automatically detect COVID-19 cases and can be used for early triage of critically ill patients. Big data analytics can also be used to identify people that need quarantine based on their travel history to predict the COVID-19 curve and to speed up the development of antiviral drugs and vaccines, and to advance our understanding of the pandemic spread across time and space. In Taiwan, big data analytics have been successfully applied to help identify COVID-19 cases and generate real-time alerts through analyzing clinical visits, travel history, and clinical symptoms. HPV infrastructure and supercomputers, they are needed to address complicated scientific problems and process big data sets in shorter time frames to develop new drugs and vaccines. The COVID-19 High Performance Computer Consortium was launched to leverage the computing resources and the supercomputers in the US. The consortium included 16 public and private entities such as the US Department of Energy, IBM, and many other academic and industry leaders. Robotics. So robotics have been applied to fight the coronavirus outbreak at its beginning. So for example, hospitals use robotics as support systems to deliver food and medicine and disinfect rooms and other hotspots without direct human interaction with patients. A CNN news report shows that doctors in Seattle have used a telepresence robot to treat the first confirmed patient who tested positive for coronavirus in the United States. So drones can also be used to deliver medical supplies, patrol public area, track non-compliance to quarantine mandates, etc. 3D printing technology can also help make face masks and other personal protective equipment for healthcare workers. So there are some companies, they produce 3D printed rayon wrapped some kind of swabs for COVID-19 testing equipment. So the swab takes less than 3 minutes to make and can be much quicker at collecting viral particles. So 3D printing technology can also be used for temporary emergency dwelling and in other aspects to fighting the pandemic. Digital tracing digital contact tracing technology can also be useful to track the movement of individuals. They can also be used to alert people from visiting COVID-19 hotspots. So especially mobile apps via smartphones and video conferencing tools can be used to track the movement of individuals, and they can help doctors to diagnose patients through video services and telemedicine. They can support people with online shopping, e-learning, online meeting, and telework. So we know various phone and network-powered apps have been developed to help healthcare workers and regular people in this crisis. For instance, the U.S. National Science Foundation funded an award to support researchers at Princeton University in developing a system to deploy a firmware update to mobile phones to provide proximity tracking ability for health officials. However, to preserve users' privacy, the key to the proximity data would be stored on the phone itself and could only be unlocked when the phone's owner voluntarily provided it to health officials. So suppose a person tests positive for a disease such as COVID-19. In that case, health officials can use the system to automatically identify all other cell phone users who are within a certain distance of the infected person for a certain time. So the time and distance can be determined by health officials based on the knowledge of the disease. Health care department can then contact those potentially infected people, advise them of the exposure, and instruct them to get tested for the disease and self-quarantine as needed. Okay, so next one is about the Internet of Things. So IoT can be used for, we know it can be used for surveillance purposes. So it can be used for the surveillance of people infected for coronavirus to reduce the spread of the coronavirus. IoT has several functional components, so including data collection, transfer, analytics, and storage. So IoT sensors can be installed on mobile phones, robots, or health monitors, and so as to collect the data. So the sensor data can be sent to the cloud server for processing, analysis, and decision making. So as an example, IoT helps check whether patients follow quarantine requirements. IoT can also be used to take the remote patient's temperatures and then transmit the data through mobile devices to the doctors to monitor, track, and alert while reducing the chance for coronavirus infections. So additionally, IoT can also include the use of smart wearable devices in response to COVID-19 in early diagnosis, quarantine time, and after recovery. Next is about the use of blockchains. So we know blockchain is a distributed ledger technology that records online transactions. It is regulated through a census mechanism and is secured with cryptography. For instance, a smartphone app that leverages blockchain technology and AI has been developed to help fight the coronavirus pandemic. Blockchain technology enables the app to give each participant a digital identity, which is controlled by a private key that brings access to a digital version of paper certificates issued by the government. So this will allow the confirmed healthy people to leave home to buy food or to work, so which has been actually already implemented in some countries. So blockchain has also been used to prevent the information from being manipulated by unauthorized parties. So for instance, during the outbreak, a Chinese payment processor and the financial services company used blockchain technology to monitor the process of processing claims and making payouts in a more secure and trustworthy way. Blockchain technology has also been applied to resolve the tension and the trust issues between mainstream privacy and addressing public health needs, such as tracking infected patients in the fight against COVID-19. So all these above technologies will require the integration of data people and the systems. So based on their primary focus and original design intention for use in practice, we can actually classify these technologies into three broad categories. The first category is data-centric technologies. So these include machine learning, deep learning, big data analytics, and HPC, high-performance computing infrastructure. The second category is people-centric technologies, such as robots, 3D printing. So they are used to serve patients better and protect healthy people from infections with the support of such type of technologies and systems. The third category is system-centric. So these technologies include digital contact tracing apps, the Internet of Things, and the blockchain. So they are developed based on system concepts to monitor patients and prevent healthy people from contracting coronaviruses. However, some of these technologies are interrelated and they may transcend multiple categories as they are being used in dealing with the pandemic. So for instance, big data analytics that identify people who need quarantine can have system-centric or people-centric aspects, depending on the specific purposes and the use by different government agencies, healthcare authorities, hospitals, and organizations. So based on the existing IT solutions, there are still some challenges that are waiting for scholars to come up with effective solutions. So we know the COVID-19 pandemic has exposed the weaknesses of the existing public health system. The use of technologies need to come back to the pandemic rate and the challenges that has been raised. So the first one is, how can we effectively connect systems to integrate technologies? So most of the systems and apps that have been used currently to deal with the pandemic are poorly interconnected. So emerging technologies, including IoT, big data analytics, AI, blockchain, they should be integrated to develop smart strategies for addressing immediate challenges caused by the pandemic. So, for instance, Facebook has used AI and big data technologies to tap into satellite imageries and sensory data to generate maps that display population density, demographics, and travel patterns to help decide where to send supplies or how to reduce the spread of the pandemic. So big data analysis of geographic information system and IoT sensor data collected from infected patients can assist epidemiologists to trace patient zero and to help identify close contacts of the infected patients. So the US National Science Foundation, they recently founded a rapid award that explores the capabilities and potential of integrating social media, big data, geospatial data, and AI technologies to enable and transform spatial epidemiology research, and risk communication. However, currently many systems and apps that have been used to deal with the pandemic, they are poorly interconnected. So because they have been developed by different government agencies, health authorities, and organizations, so there's a lack of systematic frameworks and tools to accomplish systematic integration across various technologies in the global response against pandemic challenges. So to integrate these different technologies, guidelines and the systemic efforts are required to coordinate the collection of large amount of quality data related to the pandemic. The design of effective big data analytics and AI algorithm will require public health departments and hospitals to provide a large amount of reliable and high quality data. However, due to a lack of standards, the integration of multiple data sources for promoting interoperability is still challenging. So, for instance, some data sources may be well structured while others are not. There's still a need to generate standardized protocols to facilitate communication across systems without compromising data quality, data security. Governments, leading tech companies, health organizations, and other relevant stakeholders, they need to collaborate efficiently and effectively to define the standards, protocols, data formats, and the types, etc. For us researchers, we should also offer our expertise in system integration and our experience with emergency or crisis response systems to provide recommendations and strategies to help developers with various systems and technology integration efforts. The second challenge is related to connecting data to share best practices. So as the World Health Organization suggests, new collaboration and knowledge sharing are needed to deliver targeted solutions through a coordinated effort to support countries facing stages of this pandemic in different ways and at different times. Faced with a global pandemic, all countries need to work together to share data, information, resources, effective practices, and strategies to combat the coronavirus. In addition, global collaboration among relevant stakeholders between organizations and governments will be crucial to coordinating the sharing and use of data and knowledge to address the problems we encountered during this pandemic. So, for instance, initially China took extraordinary measures for the shutdown of Wuhan, a large city with millions of people, to control the spread of the virus. Useful experience and lessons related to its efficiency as a containment measure could be valuable for other countries who are considering similar measures. Data integration and knowledge management technologies such as web portals, knowledge repositories, and online community of practices can be used to empower data connections to leverage resources more effectively and efficiently at a lower cost. Knowledge-based systems such as expert systems and intelligent decision technologies have been used to support healthcare workers in detecting and diagnosing patients and providing decision-making support for relevant healthcare stakeholders and decision makers in the pandemic. Data mining visualization technologies have been used to discover, visualize knowledge evolution across time and locations as the coronavirus outbreak continues to evolve. Online health communities have been developed to help healthcare workers, patients, and other people to learn about the pandemic symptoms and the effectiveness of the treatment. However, all of these efforts and initiatives and the systems, they often operate in a silo. As a result, the data, information, and knowledge stored in these systems are not widely shared. So, therefore, to allow various systems and stakeholders in different communities of practice to share knowledge within and across their individual areas, we will need to create an environment to encourage people across countries to share knowledge instead of keeping or holding the knowledge. So particularly strategies should be developed to assess the quality of the knowledge and to help system break down silos. So in order to facilitate communication and the data sharing. In addition, behavior issues will also need to be addressed in order to facilitate the sharing of data and the best practices among stakeholders. So we know over the years there have been a number of calls for information system and technology researchers to consider the unintended or negative consequences of technologies, like the dark side of IT and IS. So IT professionals have been rushing to build apps, services, and systems for contact tracing, tracking, and quarantine monitoring. So we know some of these technologies are lightweight for short-term use, while others are pervasive and invasive. For instance, many researchers have advocated the use of digital contact tracing and health code apps to reduce the spread of the disease. Some people are concerned about short-term fixes, such as monitoring of infected people through an app, could lead to a permanent state of surveillance by the government. So digital contact tracing can be effective, but it's also controversial because it could have disastrous consequences if not implemented with proper privacy checks and encryption. Some experts are questioning how anonymous the data is used and whether it can be easily de-anonymized to identify or infer the personal identity of infected persons. Health authorities may misuse or abuse the data they collected from digital tracing mobile apps for long-term and other purposes. Many people are concerned about whether these coronavirus fighting apps are secure to use and how these apps will preserve privacy and what policies are needed to prevent the abuse. These concerns are likely to undermine public trust and affect people's adoption of emerging technologies. So therefore, there's also a need for further research to investigate security, privacy, and ethical issues related to technologies developed for fighting this pandemic. So even though knowledge about coronavirus exposure is important for containing the spread of COVID-19, public trust and confidence are also necessary to the adoption of technologies to facilitate data sharing to address the challenges caused by this pandemic. Some researchers think that it is justified to temporarily relax privacy measures for such technologies in the hopes of possibly saving lives, serving the public good, and protecting public health under pandemic situations. So we know many people have been engaged in self-disclosure on social media to share personal information, such as health status and preventive behavior, Some researchers hold that privacy concerns should not decrease the usefulness of technology to protect public health. However, they do not think such technologies were designed to make a permanent change to the society. The lack of a consensus on privacy protection in technologies against COVID-19 indicates a strong need for establishing best practice guidelines to reassure citizens on data collection. So currently, the adoption of digital contact tracing apps is voluntary in Western countries. It has been recognized that these issues cause more controversy in Western countries with a culture of individualism, such as Europe and the US, than in countries with a culture of collectivism. So at least 60% of people with smartphones would need to opt in for such apps to be effective. However, how to incentivize mass users' adoption of these apps is a challenge. So in the context of this pandemic, with a lot of loss of life, information system and information technology scholars can help evaluate the use of digital data in the technology, including AI-related algorithms, in a responsible manner to provide oversight for user-related data, to develop ways to incentivize users to share relevant data as needed, to help develop mechanisms to ensure that technology design and use are guided by ethical principles. So in order to ensure transparency, equity, and security, to increase public trust and confidence. Our researchers can also help identify best practices to implement responsible data collection and data processing to achieve a balance between privacy and the utility of the proposed technologies. Next challenge is related to connecting people with enhanced collaborative tools and IT infrastructure. The pandemic has rapidly changed the landscape of the workforce and the workplace. Millions of people are moving their workspaces to their homes through teleworking. Many industries benefit as knowledge workers learn to operate virtually, work from home, and use cloud services to process and store files. So we are witnessing wider acceptance of online services by people in the diverse types of industries during this pandemic. At the same time, we also have witnessed the importance of IT infrastructure in enabling teleworking, online learning, e-government, e-commerce, and other online activities. The pandemic has forced a record number of employees to work remotely for an extended duration, which has resulted in heavy traffic on remote connectivity networks. So that's why there are vital needs for the society to continue investing in IT infrastructure and accelerate digital transformation to deal with the impact of the pandemic and the future public health crisis. So companies, they need to enhance their investment as well in the tools such as video conferencing, group decision-making, and collaborative systems to enable personnel and distributed teams to work remotely, to collaborate virtually. On the other hand, the cost for IT infrastructure is exploding as employees practicing teleworking and when students take online classes during the pandemic. So it is necessary to understand the rise in the cost of IT infrastructure associated with meeting spiking demand. As the pandemic continues to evolve, IT infrastructure will need to be enhanced for workers to perform their duties safely and healthily. Some critical tasks may not be executable from home, and the workarounds will need to be identified. It is particularly necessary to identify the factors that drive the cost of serving the increased demand due to teleworking. The cloud services should also be further leveraged through existing infrastructure, such as Google Cloud, Azure, AWS, or many others. Strategies will also need to be developed to keep essential functions and services up and running. CIOs, they will also need to think about retrofitting the present for the new needs for creating new systems for new situations. So digital infrastructure readiness and resilience are also important topics to be explored. So we know group decision making is often needed for complicated situations with much uncertainty and time constraints. So IT and IS researchers can share their experience with group decision support systems to support collaborative decision making regarding the evolving pandemic, to help connect stakeholders at different levels to build consensus, and to support governments, health authorities, organizations, and the public to make culturally appropriate and sensitive decisions regarding the infection detection, infection prediction, and infection avoidance, and about when to reopen the economy and when to enforce the quarantines. Information and information technology researchers can also help build collaborative information systems, community-based information systems, talent and volunteer networks to leverage the expertise in the time of various stakeholders. So that's the third challenge. And next challenge is about studying human behavior with technologies in the digital divide. It's important to study human behavior when designing, building, and using technologies, as more pandemic-related technologies are being developed, integrated, and used by government, organizations, and people. Lots of efforts to combat the pandemic incorporate new technological advances and approaches in integrating various systems and innovations. However, we also need to acknowledge that people's misbehavior with technologies may reduce the effectiveness of the technology-related interventions or countermeasures on containing the coronavirus outbreak. As a result, our researchers can contribute by incorporating their understanding of human behavior into the technology design and development process, leading to more effective technology. A large number of theories and models, such as the technology acceptance model, innovative diffusion theory, the theory of reasoned action, health belief models, and the theory of planned behavior, social cognitive theory, and motivation theory, they can all be used to explore the acceptance and use of COVID-19 related technologies, such as telehealth technologies, such as to study the strategic role of various technologies in dealing with the pandemic, as well as to examine unintended consequences of using these technologies. For instance, researchers can investigate online users' information sharing behavior to study how online patient communities should be engaged and incentivized to share information and to support COVID-19 patients and caregivers. And we can also analyze data to reveal new insights to support policy making for health departments and medical knowledge discovery. At the same time, during the pandemic, we also have witnessed a digital divide. There's an increasing digital divide during the pandemic due to people's uneven access to digital content and connection. So this refers to the uneven access to the digital content because of some people may not own or have easy access to technology. People's ability to use technologies is also different. As emerging technologies such as mobile apps, AI, IoT, and big data analytics are increasingly used to fight the pandemic, existing disparities, inequality, and biases need to be further reinforced. So this kind of a disparity, inequality, and biases, we have observed they are actually being further exacerbated. As people spend more time working, learning, socializing, and shopping online at home, this pandemic provides a chance to assess the issues and the challenges faced by the rapid digital transformation of organizations and how the digital divide impacts people. For instance, underprivileged populations, women, workers in healthcare, elderly citizens, and those at risk. Therefore, information system and technology scholars need to help develop strategies and approaches to address digital inequality and disparity, especially when the governments need to flatten the curve of infection. Technologies can play a significant role in improving the visibility of digital inequality and disparity in organizations and communities. People of color communities tend to have relatively lower public health literacy and less experience in finding and evaluating healthcare information. So scholars can investigate to what extent the marginalized women, elderly, and people of color are engaged, included, and impacted by the pandemic-related applications and systems. Therefore, trying to bridge the gap and try to help those negatively impacted by the technology during the pandemic. Researchers and scholars can do their part to improve technology design and processes to promote digital inclusion, assist with efficient development, and sustainable implementation of the proposed technology, particularly for those underserved populations. So, for instance, in the recent studies, the scholars, they show that technology-mediated online health communities can share information and alleviate rural-urban health disparities. Online health communities can also support the most vulnerable family caregivers. Information technology scholars can explore factors affecting underserved populations and communities to adopt and effectively use emerging technologies, encourage information sharing behavior during this crisis, and identify strategies to incentivize the mass adoption of relevant pandemic fighting technologies by underserved populations. So, understanding the underserved populations' unique perspectives in the pandemic can provide guidelines for future IT system and application design development, and potentially improved adoption and use of IT systems. Okay, to conclude, the pandemic has produced significant impact on people, business, and the society. At the same time, the pandemic has also brought implications for the design, development, and the use of technologies. Technologies can be useful for reducing the severity of the pandemic's impact on people, organizations, and society. However, the use of technologies to fight the pandemic raises challenges such as security, privacy, biases, ethics, and the digital divide. So future pandemics are also likely to come. So while information system and technology scholars may not be able to help with the scientific aspect of developing vaccination and the treatment directly, we can contribute our knowledge, experience, and the time to help society better prepare for future pandemics. To mitigate future pandemics costs and improve data sharing during global public health crisis, so we need to establish a global common data space for highly infectious diseases. So even though it's very challenging to establish a global common data space for public health data sharing due to various reasons, we will need to support this initiative to promote the benefits and the broader social good. So at this stage, as an IT researcher, we can help advocate and build a national common data space of health information systems for public health data sharing. Solving grand challenges face society requires significant financial and human resources. To increase the importance and relevance of information systems in the technology research, we will need to encourage scholars to actively apply for various government and industry grants, including various COVID-19 funding opportunities, to get financial support to put some of their research ideas into practice. So, for instance, the US National Science Foundation and the National Institute of Health have grants programs to support technology-related researchers to address challenges caused by the pandemic. As an IT researcher, we should get involved by leading or joining an interdisciplinary team to write grant proposals and get funding to directly work on some of these research ideas. Furthermore, many students, including undergraduate and graduate students in our area, they are looking for internship opportunities. So many small businesses in the industry, such as tourism, food service, and retailers, they are also being hit hardest by the pandemic. So we could also collect student resumes, put them on a Google Drive or on a website, and share the resume with interested small business owners. This will help match information systems and technology students with interested small businesses or nonprofit organizations to solve the technology and other issues they may have during the pandemic. So some of our faculty, they are already doing this, and they are mentoring small business owners on developing or deploying digital technologies to deal with the challenges of business continuity, to help facilitate digital transformations for small and medium-sized companies. So some professors, they have been involved in digital solution development projects to organize similar events such as online hackathons to gather people with diverse skills to work on solutions to help the society to fight the pandemic. So we look forward to seeing more researchers in our area to be involved in building and expanding technology volunteer networks and to mobilize community resources and services to fight the pandemic. So at last, some of the developed technologies and applications for this pandemic may cease to be useful after the pandemic ends, but many will likely to be retained, enhanced, or repurposed for other uses, in which information systems and technology scholars can continue to play a role after the pandemic. So for instance, there are many questions will remain to be addressed. For instance, will data collected from mobile contact tracing be destroyed after this pandemic? What data management policies are needed to prevent the abuse of the user data and guide the improved design, development, and use of future mobile contact tracing and tracking tools? So these are some of the future research questions we may help to address in our future studies. So in summary, the specific nature of the COVID-19 pandemic will require strong coordination for connected data people and systems to facilitate worldwide collaboration. Okay, so that's all my presentation. Thank you very much for your attention.
Thank you very much, sir, for a remarkable speech. I hope this speech will give an idea for the researchers who is working in COVID-19 solutions. And sir, as you discuss the existing IT solutions like IoT, blockchain, digital tracing techniques, how they can be useful to diagnose the COVID-19. So this speech was very useful, remarkable, and informative speech. I'm very happy to see that the researchers from India will have a impact of this speech, and they will implement whatever the suggestions given by you, what are the challenges you discussed, and what are the open still some problems are there as you discussed, sir. We need to be address those problems. So this speech was very impactful, sir. I'm very happy to have you in this conference, sir.
Thank you very much. Thank you again for your invitation.
Yeah, sir. Now I would like to ask the participants if you have any questions to Professor Justin. You can just raise your hand. I will unmute you. You can ask the question.
Sir, I would like to ask a question.
Yes, ma'am. Please go ahead.
Good morning, sir. Firstly, Justin, sir, good morning.
Yeah.
Sir, we have this COVID-19 pandemic analysis, and the reports we have several algorithms that are built on data science, right? Do you really think that is it going to provide any kind of solution for future analysis of it?
So you said you have the report based on data science for the COVID-19.
Okay.
Yeah, so you said that will, I think if you can do a good analysis based on the data science technique, it will be it can provide some very good guideline maybe for the future pandemic or epidemic.
Okay, sir. Thank you.
You're welcome.
Yeah, participants, any other doubt you want to ask? Sir, I have one question for you.
Okay.
Yeah. As you discuss about COVID-19, right now we can diagnose using these IT solutions. So is there any technology which can prevent the spread of Omicron? Because right now Omicron is spreading in a very fast speed. So how can we stop, or how can we identify Omicron in a person using this current technologies?
That's an excellent question. I think Omicron is relatively new. I think the technology we have, I think, is similar to the previous kind of version of the virus. So the only way is because it's more contagious than the previous version. So maybe we'll need this the technology to maybe to reinforce the current maybe use of the IoT blockchain, those kind of AI to maybe, but I don't think technology will be much useful in this case, because Omicron essentially, even though it's the same version of the virus, it's more contagious. I think that maybe the behavior kind of measures should be taken at the same time with the technology to combat, to more effectively to fight the pandemic.
Thank you, sir. Once again, I thank you, sir, because right now you have, I wholeheartedly welcome you in this conference, and you have a challenge that in India it is morning round, in USA it is night. So somehow you accepted our invitation. I am very grateful for that. And I look forward to have you in my future conferences, sir.
Yeah, me too. I look forward to meeting with you in other conferences.
Thank you, sir. Thank you so much, sir. You can stop sharing, sir.
You're welcome.
Thank you, sir. Thank you. Swati ma'am,
Sir,
please go
I'll
ahead.
take on, sir.
Yeah.
I thank all the authors, participants, session chairs, and the keynote speakers for gracing this occasion. Now we have a 15 minutes break, and then we are going to join back at 11:15 for fourth keynote speech. So I request all the participants to stay back and take a break of 15 minutes and then join back.
Yeah, thank you.
Thank you. Welcome back to all the participants, authors. Our keynote speaker has already joined the session, so let's begin the session. Now we have fourth keynote talk on numerical association rule mining using population-based nature-inspired algorithms. Recent advances by Professor Dr. Istok Pfister Jr. Sir received the BSc, MSc, and PhD degrees in computer science from the University of Maribor, Slovenia. He is currently an assistant professor at University of Maribor. He is the member of IEEE and he has published more than 120 research articles in referred journals, conferences, and book chapters. His research interests include data mining, pervasive computing, optimization, sports science, etc. He has acted as a program committee member of more than 30 international conferences. Furthermore, he is a member of editorial boards of 5 different international journals. We are glad to have you here, sir. We welcome you to the conference. I request sir to please take over the session.
Hello.
Yes, sir.
Yes, you hear me.
Yeah. Hello, Professor Ister. How are you?
Oh, thank you.
Yeah, very good morning.
Yes,
This is Dr. Ashwari from India.
Okay, yes. I'm just checking if you hear me in good enough.
Yes,
yeah,
yes,
it is
sir.
good. Just we want
Okay,
to see.
thank you.
Can you please on your camera? Just we want to take one screenshot.
Yes, I think I have a problem with the camera, so I hope you will see me enough.
Just a minute. I'll spotlight to everybody. Okay. Can you please stop sharing for a while so that it will be coming in the big screen?
Okay.
Yeah.
Stop sharing.
Just for a second, you can stop sharing. Then yeah, it's perfect now. Yeah. Light. Correct.
It's dark, I guess.
Professor Stuck, do you have a light there? Can you make some light there?
Yes, I think I just realized that something is wrong with the camera. So I think...
Yeah. We can see you, but the brightness is not that much. Good.
Yes. I think that is the problem of the camera. So
no issue. You go ahead, please share your screen. Go ahead. No.
I'm extremely sorry. I just realized today that camera is not working.
Professor Stuck, absolutely fine. No issue. You can go ahead.
Okay.
Right. You can share the screen.
Okay. Thank you once again, dear participants, dear organizers. Hello, everybody from Slovenia. I am extremely happy to be the part of this conference. This is a very interesting conference, and I'm happy that organizers invited me to be a part of this event, of this inaugural event. So I must congratulate to the organizers for the organization of this conference. I really hope you have a good time during the sessions here. I also hope that you all are healthy in these challenging COVID times. We also have some problems, still have some problems with the COVID, and I really hope that it will go away very soon. So it will be possible to meet you in person very soon. So today I have prepared one talk. This talk actually encompasses two topics where we are very active, me personally, as well as lab in which I am. So in this talk, I will actually connect two contemporary topics in computer science. So in the first part, I will talk about population-based nature-inspired algorithms. And in the second part, I will show the application of these algorithms in numerical association rule mining. So I think I won't spend one time slot. I may finish before 1 hour. So I try to reserve some time for discussion. So I would be very happy to answer questions. So if you will have questions, please ask me. Otherwise, you can also send me questions or dilemmas or anything for discussion on my email. I will be very happy to answer the question. So for today, I prepared two parts. The first part is a little bit more theoretically oriented. In the first part, I will try to show you a brief outline of nature-inspired meta-heuristic algorithms. I will talk about theory of evolutionary algorithms as well as swarm intelligence algorithms. I will also show some problems in this research area, especially connected with the emergence of new nature-inspired meta-heuristic algorithms. And at the end of this session, I will also show some software tools which can help you to apply or use these nature-inspired algorithms. So the part two actually will, besides the theory, also present some practical applications of numerical association rule mining. I will also show the architecture of this numerical association rule mining algorithm. In this part, I will also show one example of results as well as some software tools that were developed in our lab. And we will wrap up this talk with the future paths of the numerical association rule mining methods. So maybe just a few words about me. Organizers made a really good presentation about me. So I think I can skip this slide. Maybe before we begin, I would like to show maybe some selected works of me and my colleagues. So in the past years, maybe about 10 or 7 years ago, we were very active in the adaptation and hybridization in computational intelligence. We developed some meta-heuristics, especially hybrid variants. So we also published many papers in this research area. In line with this, one edited book was also published, which encompassed some recent advances in the field. Then in recent times, maybe in the last 3-4 years, we are very active in research which connects artificial intelligence with the sports science. So in this research area, we are developing theoretical as well as practical models where artificial intelligence algorithm, especially computational intelligence algorithm, are used in the sport science tasks. In this case, we try to develop artificial sport trainer. Artificial sport trainer is actually a digital twin. And our goal is to create an artificial trainer who will have the same abilities as a human trainer. So we try to replace human sport trainer with the artificial sport trainer. So the potential is that all people who actually don't have money to hire a sport trainer can be able to use this free solution. So artificial sport trainer in the realm of application, mobile application or web application, and they will also have a possibility to have generated training sessions in order to help you to improve their goals. So I am also a member of several program committees at the moment, as well as I spent a lot of time with my role as associate editor in Expert Systems with Applications journal. So this is a very good, very strong journal of Elsevier, and we receive extremely high number of submissions every year. So this number is rising, and I spent a lot of time. Nowadays, I really spend a lot of time for editing papers, sending the papers out for review and making decisions. So this task is extremely time-consuming at the moment. So I still try to do research, not only editing papers. So if we start with our first part, which is tailored to the stochastic population-based nature-inspired meta-heuristics, we have to mention that there exist two bigger groups of stochastic population-based nature-inspired meta-heuristics. So the first group are evolutionary algorithms. They are inspired by Darwinian evolutionary theory, while the second is swarm intelligence. So it is inspired by the behavior of social insects. Both groups are basically intended for solving optimization tasks. So for both domains, continuous as well as discrete domains. In fact, all methods offer enormous possibilities for solving the real-world optimizations. Here I mean many different problem groups, for example, scheduling, or maybe graph coloring, or many problems from the combinatorial optimization for maybe numerical optimization of benchmark functions. In fact, we can use all of these methods in all problems that can actually be represented as optimization problems. They're also useful for solving machine learning tasks. For example, we can solve classification tasks using these methods. So they are very popular at the moment, maybe for many decades, and they are also used in industry. For example, major players in IT fields also use these algorithms for solving their tasks. So, as the name say, nature-inspired meta-heuristics are actually inspired by the nature. So they are actually mimic the behavior of some fascinating behaviors of different animal species, like for example, bees or ants, natural evolution, physics and chemistry-based phenomena, as well as different areas of our life, as for example, sport or society. So in fact, these algorithms are based on some phenomenon from the nature, and this phenomenon is represented by the mathematical formula and is intended for solving optimization tasks. So if you are interested more about this inspiration of these algorithms, I invite you to read this paper. This was co-authored by us approximately 10 years ago. In this paper, we tried to make a taxonomy of inspirations for these algorithms. We mentioned also more than 80 algorithms grouped in the group, and maybe you can get some first insights about the inspiration of these algorithms. So if we go slightly deeper in details in the theory of evolutionary algorithms, so the evolutionary algorithms are inspired by Darwinian evolution, which actually said that the fittest individuals in the generation will survive as well as reproduce to the new generations. So in evolutionary algorithm, we have three main variation operators, namely selection, crossover, and mutation. So in this figure, which I found on the internet and is really nice, it depicts the whole evolutionary process. You can see the main parts in this algorithm. So at the beginning, we have a group of individuals, random individuals, which are at the beginning of the cycle evaluated. So we calculated the fitness of them. And after this step, we go into the main loop where selection, recombination, and mutation takes part. So after this variation operators, new generation is created, which again step into the fitness calculation, and we repeat this cycle until the termination condition not meet. And at the end of the cycle, we select the best solution. So during the evolution of this research area, many variants of evolutionary algorithms have been proposed in the literature. For example, genetic algorithms, genetic programming, differential evolution, evolutionary programming are the main members of this family. So they differ usually in the representation of solutions. For example, in genetic algorithms, individuals are presented as bit numbers, while differential evolution is represented by the real valued, by floating point actually, vectors in evolutionary programming and genetic programming. So the individuals are presented as the programs, especially in genetic programming. So it usually depends on the representation of individuals as well as variation operators. On the other hand, swarm intelligence algorithms, which are the second group, algorithms are inspired by the social behavior of some species of animals. And theory says that swarm intelligence concerns the collective emerging behavior of multiple interacting agents who follow some simple rules, as for example, bees when they are foraging, or ants when they are foraging. So while each agent may be considered as unintelligent, the whole system of multiple agents may show some self-organization behavior and thus can behave like some sort of collective intelligence. So on the figure, we can see the process when ants are foraging. So when ants are foraging, they're leaving the pheromone trails, and these pheromone trails attract the other ants to follow the path. So more pheromone, better path to the goal. During the decades of research and development in this field, many algorithms were proposed, as for example, the first two members were ant colony optimization and particle swarm optimization, but from maybe 2005 until now, also other algorithms with different inspirations appeared in the literature, as for example, artificial bee colony, or firefly algorithm, or cuckoo search, maybe bat algorithm, gray wolf optimizer, and so on. So there exists extremely high number of algorithms in this field. So this is a pseudocode of a very simple nature-inspired meta-heuristic algorithm. I think we can skip this because we solved the whole pipeline in the figure when I presented evolutionary algorithms. It's practically the same representation, but we can continue with the interesting research question. So how many nature-inspired meta-heuristics exist? Currently, I can say that there exists probably more than 300, 400 algorithms. As I mentioned earlier, we published one paper 10 years ago where we grouped 80 algorithms to the 4 groups. But nowadays, after 10 years, there exists more than 300 algorithms. So it's actually also impossible to find all of the members. There several catalogs of algorithms exist, but unfortunately, they don't cover all algorithms. Some algorithms are also published in local languages, not in English language. So this is also a problem for researchers to make a taxonomy also from these algorithms. And unfortunately, the number is increasing every year. We will see the problems, why it's not good that number is increasing every year. So if you want to see maybe a catalog or a list of algorithms, I refer you to this paper, a comprehensive database of nature-inspired algorithms. So we compiled a list and published this paper in Data in Brief. So there exists also a data set in Mendeley data, so you can download and explore also more details about these algorithms if you are interested in this area. So what are the features of new population-based nature-inspired algorithms? As I said earlier, so number is increasing, but the problem is that the concept is actually the same as used by the existing algorithms. So new algorithms or metaphor-based algorithms are usually without any special novelties, without any special modified formulas or steps. Usually inspiration is only a camouflage for selling the new algorithm. With the selling, I mean publishing and then sharing the information about the new algorithm. Many research works also show that it is almost impossible to compare inspiration with the real biological system or the system which serves as an inspiration for researchers who created this new algorithm. And at the end of the day, we can say that these new algorithms are mostly created because of publication and citations. Because we live in a very competitive world, and I say that publishing work is nowadays extremely competitive. So we entered the era of publish or perish many years ago. And this research area is nowadays spoiled with the many approaches that are actually just reused of many algorithms that appeared many years before the introduction of these new algorithms. So this is probably the consequence of publish of perish area. So for example, for you to get a feeling what kind of really strange inspirations are nowadays proposed. For example, some researchers used zombie foraging as an inspiration for the development of these algorithms, or maybe sperm motility search. So it is amazing what kind of inspiration or metaphors researchers use, and they actually publish papers, and they also receive citations for these papers. So I think this is the anomaly nowadays, that such inspirations actually enter the research works and enrich the existing literature. So in this graph, you can also see how many algorithms appeared per year. I don't have no numbers for the 2020, 21, 22 because I ended counting these algorithms. So maybe about 2014, 2015, there was a peak between 15 to 20 algorithms per year, but today I think number is going up to 30 or 40 per year. Maybe one more slide about the implications of the new population-based nature-inspired algorithms. So we can say that they are excellent bait for students and junior researchers. Usually, proposers of these new metaphor-based algorithms make a very strong statement about the performances of their algorithms. So they write very strong claims in the paper that their algorithm is the best, or that their algorithm outperformed all of the existing algorithms. So the students then see this claim, take this algorithm and use this algorithm for research. So this is not good. I think I also felt in this debate maybe more than 10 years ago when I saw some interesting metaphor-based algorithms. But nowadays, I try to rely on this existing and I say famous algorithms, as for example, differential evolution or particle swarm optimization. So the second problem is that literature on this subject is rising. Nowadays, it's hard to find what is really good because in this research area, we faced so many research papers per day. So you spend a lot of time for reading and actually filtering the good research from the pool of new research papers that are published each day. So we entered also the reproducibility crisis. A lot of these research papers are not reproducible. So there don't exist any specific source code, or some researchers also tried to reproduce the results according to the pseudocode proposed in the research papers, and they are unsuccessful. Additionally, some algorithms are mixed up. So, for example, cuckoo inspired algorithms. So we found research papers when authors mixed up the theory of two different cuckoo inspired algorithms. So the first part of algorithms presented one algorithm, while the second part of algorithm presented the second algorithm. So the whole algorithms was totally mixed up. But a very good, interesting fact is that people from industry usually do not care about the origin of algorithms if they work well. So this is a interesting fact. I heard this claim many times when people from industry come to us. So usually they use a pool of algorithms, they test on their problem, and if the algorithm work well, they use it. So I can say the industry is slightly different than the academia. So if you are interested in these algorithms, I would like to show you some open source implementation of some algorithms so you can use them for your own research. Most of these algorithms are also licensed in license that allow you to use it in your industry applications. So you can use it also for commercial applications. A lot of software is actually written in Python. Python is very popular nowadays for artificial intelligence research. So if you are familiar with Python, you have a lot of libraries to check it out. Java is also very popular for this research. So there exist several libraries, software tools, which offer the implementation of main nature-inspired algorithms. And you are also able to find implementation in other languages, as for example, C++, Julia, Rust, Haskell. So I think in each language, programming language, you can find some implementations of algorithms that are inspired by the nature. So here I must devote some words to the Neopine framework. So Neopine framework is a project that was developed by us. So we started this project in 2018, and up to date, there exist more than 1,000 commits in GitHub repository. So our goal was to implement more than 40 different algorithms. We also provide a very nice interface in Python, so you can easily use and apply these algorithms. There exists also a very good documentation with a clean presentation of this framework. It allows also researchers to study the mechanisms of various algorithms because of the clean implementation. You can find also many examples in the folder. So I can assure that it is not hard to start with this framework. So you have a lot of documentation, you have a lot of algorithms implemented, and they are the software is licensed by MIT license, so you can use it in your commercial applications as well as for your research. So this is the GitHub link, so you can check it out, this NeoPy framework, and I really invite you to check it out, and if you find it interesting, you can use it for your research. We also developed some software tools libraries that are based on NeoPy framework. So there exists also one automated machine learning library that's based on these algorithms. So you can use this library for AutoML for the classification task. There are also some libraries that presents hyper-tuning the machine learning parameters. So if you're interested, just drop me an email and I will send you links of these software tools. So I think now we can go to the second part of this presentation. Now we will enter the area of data mining with nature-inspired algorithms. So we will devote the next minutes to the numerical association rule mining. So before we introduce the term numerical association rule mining, let me stop with the term association rule mining. So I believe you are very familiar with the association rule mining, or ARM, which is a data mining method. Its origin is in 19th and up to date they are considered as a, so association rule mining is nowadays considered as a algorithm included in top 10 algorithms in data mining. I mean, a priori algorithm. Association rule mining is used a lot in industry for different tasks. For example, for market basket analysis, for building different intelligence systems, for building rule-based classifiers. So this research area is also very popular among researchers in computer science. Although this association rule mining appeared more than 30 years ago, we can say that frequency of papers each month is still high. So it means that research area is important as well as popular in the research community. So the task of association rule mining is actually to find relationships between attributes in a transaction database, while these relationships are presented as implications, where the left side of the mined rule represent the antecedents and the right side represent the consequent. So association rule consists of two parts. From the left side and the right side. On the left side we have antecedent, while on the right side we have the consequent. So this is the mathematical presentation of association rule mining. I think I can skip formulas for now, but I must tell something about the two evaluation metrics or measures which are defined for evaluation of the quality of an association rule. So in the basic association rule mining, usually we deal with two evaluation measures, confidence and support. So support is actually an indication of how frequently the item set appears in the data set, while confidence measure is the percentage of all transactions which satisfies X that also satisfy U. So both two measures originates from the introduction of association rule mining, and they actually both measures play a very important role in the most of the rule mining algorithms. So nowadays there exist many methods for association rule mining, so you can easily identify which one is appropriate for your problem. So the first algorithm was actually a priori algorithm that was proposed by Agrawal in '94. So the original publication of this algorithm was cited more than 20,000 times. So from this number we can see the popularity of this algorithm. A few years after the introduction of a priori, ECLAT and FP growth algorithms were proposed. They are slightly different and they are more efficient because a priori is very time consuming if we deal with very big data sets or with big data. But today, nature-inspired algorithms are very popular path for the development of methods for association rule mining. So they are the base, and new methods are actually based on the nature-inspired algorithms. I will show the reasons in the next slides. Some numerical association rule mining is a popular variant of basic association rule mining. So in the basic or conventional association rule mining, algorithms are not able to deal with numerical attributes. So before we apply, for example, a priori algorithm, we must make discretization of data. But the problem is that if we make a discretization of data, we lose some information, as well as we add some noise in the data. So by the end of the day, we can realize that results may not be so accurate because the presence of noise. On the other hand, in order to break this wall, numerical association rule mining algorithms were proposed. In this case, numerical attributes are handled without discretization. So the main benefit is that an algorithm can operate directly, not only with categorical, but also with numerical attributes. And in this case, we can get more accurate results that have more practical value in the real world, especially in the industry, where people in industry usually tend to have very efficient as well as accurate results. Yes, so evolutionary and swarm intelligence-based algorithms show a big efficiency for dealing with this problem. In this dendrogram, I would like to show some methods that were covered in our recent review about this research area. So as you can see, PSO, particle swarm optimization, and colony optimization, beta algorithm, all of these algorithms were actually used as a base for the development of numerical association rule mining algorithm. PSO is probably the most popular swarm intelligence algorithm for association rule mining. However, there exist also many variants that are based on evolutionary algorithms. From this perspective, you can find many algorithms for solving these tasks that are based on differential evolution. So I can say that both groups, swarm intelligence as well as evolutionary algorithms, there exist more than 20 or 25 different algorithms for numerical association rule mining. So why is numerical association rule mining important or even popular? Why should we work this research area, or why should we invest time when we work in the industry and use this approach for our problems? In fact, as I said earlier, these algorithms offer us not so much loss of information. We avoid discretization step. Additionally, the whole pipeline is usually less complex. We don't need to perform so many special data pre-processing tasks. For example, discretization task is sometimes very time-consuming for us, and there exist also some steps in this discretizations that cannot be handled automatically. So we need to invest some power in this step. More accurate results are probably the most important goal of numerical association rule mining. On the other hand, or consequently, most of the algorithms for dealing with numerical association rule mining are more complex. So with this claim, I mean that evolutionary algorithms can be more complex because we can use some hybridization schemes or maybe some adaptation schemes in order to enhance these evolutionary algorithms, and potentially this algorithm becomes much more complex as maybe some conventional algorithms. But this is optional. Usually enhancing the algorithm, we enhance the algorithm when we see that existing algorithms has some problems or has some drawbacks. So we try to enhance this algorithm, and potentially it becomes much more complex. So I must present one very simple recipe. So how to apply one nature-inspired algorithm for this task. In fact, we just need to perform two key steps. So in nature-inspired algorithm, so the first step is we must modify or adapt the representation of solutions, while we need to propose a definition of the fitness function. So for example, how here is one example that was developed by us. So in this algorithm, I show the one basic representation of solution. So this representation is in Michigan style. It means that we represent one association rule one association rule in one vector. So one vector represents one rule, association rule. In this case, we can see that we have numerical attributes. So the first one is numerical attributes, which is represented by two borders, lower and upper border. While on the right side, we can see the categorical attribute. Categorical attribute is actually represented by one category. And at the end of this representation, we also have one cut point. Cut point denotes the cut point. It means that with the cut point, we get two parts. So the antecedents and the consequence, and cut point is also enters the evolutionary step. So this is one of the possibilities how to represent one association rule in the vector, in the real point or floating point vector. So potentially it means that very big data sets which have many features will be very big vectors here. So it means that in practice, if we have very, data sets with a very huge number of features, it means that we also need a lot of memory on our hardware in order to deal with it efficiently. So this is the problem for bigger data sets. But if we deal with maybe normal or small data sets, then there's no any special problems. So association rules can be easily and efficiently presented in this vector. So in evolutionary algorithm, we always deal with evaluation function or fitness function. So this fitness function evaluates the quality of solution. In association rule mining, we need to develop or design a new fitness function. As you can see here in our proposed fitness function, we use confidence and support measure, as we can solve in the previous slides. So in our case, we apply some weights to the confidence and support, and we try with these weights to make priority, maybe for confidence or support. So typically the weights are the same. So the weights are usually one, the number one. It means that there is no priority between confidence and support. So both measures have the same influence in the fitness function, but sometimes we have a favorite. So many times we give us priority to the confidence. So in this case, we decrease the weight for the support, or maybe increase the number for confidence. So here we deal with only two evaluation metrics, confidence and support. But on the next slide, you can see that there exists many other metrics that can also be included in the fitness function. For example, interestingness, or comprehensibility, or conviction, or lift, and so on. So usually, as I said before, that algorithms are more complex. So these evaluation metrics can also make algorithm more complex. So if you are interested in more details about this representation as well as evaluation metrics, I invite you to read our latest overview or review paper in this field. So you can find it also on arXiv, and you can download it and read. So there is much more detailed explanation of this evaluation metrics as well as the algorithms that are mentioned on this slide. So where we use this numerical association rule mining in practice. So we can use numerical association rule mining actually on when we deal with data sets in many areas. So if you are interested in genetics and you deal with maybe gene data, you can use numerical rule mining without any limitations. You just need to prepare data set that be able to enter the pipeline. In marketing, you can analyze data, market data. Then in sport, you can search for association rules in training data, or maybe in some data that present physiological data of athletes and so on. So for example, in our case, we are developing artificial sport trainer. So numerical association rule mining plays a very important role. So when someone is riding a bike, so we have one special monitor or a small Raspberry Pi computer, and this computer is monitoring all the data in training, and these data are then sent via API to the cloud, and on the cloud, numerical association rule mining algorithms are searching for the rules, and then these rules can in real time be delivered to the athlete, so he can adapt the training according to the results or that are hidden in association rules, and this helps an athlete to have much more efficient training. So in this case, during the training, we collect monitor data. Data are sent to the cloud, and on the cloud, association rule mining algorithms run. They provide results, and results are then delivered to the athlete. So for example, one very simple example of solutions, in this case, we deal with different features, calories, altitude, duration, distance, ascent, and all these rules actually defined one feature of the training, and these rules helps the trainers to implement much more efficient, much better training plan. So for the end, of this talk, I must stop with the software tools. So in my lab, we develop 2 software tools that are intended for numerical association rule mining. So the first tool is Universal Association Rule Mining Solver. This framework is fully written in C++, so you can compile and run this framework on all platforms, and all pre-processing tasks are included in this software. You can also make discretization of data, and you can search for association rules. At the end of the pipeline, you can get also visualization guide that can be then later using by the external tools. In this case, you have a very nice presentation of results. So results are generated in CSV file, so you can make a very easy analysis, as well as you can also use these results in your research papers. So this software is licensed by MIT license, so you can use it in academia as well as in industry. So the second framework was written in Python. This framework is also now under heavy development. This is very similar to the Universal Association Rule Mining Solver, but in this case, more evaluation metrics were developed. This is also here you have also very nice API in Python. You have also a lot of examples. Documentation is very well developed. So it's easy. It's very easy to use, and this implementation is also very efficient. We will also add some parallel implementations in order to easily deal with bigger data sets as well as with big data transactions. And what is the good point of this NeoPy framework? It practically means that you can use 40 algorithms that are implemented in NeoPy for solving this rule mining task. So here you have a big pool of algorithms that can be used here. So for the conclusion, I can say that in this talk, I briefly outlined 2 research areas. The first one are the nature-inspired meta-heuristics or stochastic population-based nature-inspired algorithms. They are very efficient tool for coping with optimization problems. The topic is very contemporary as well as popular among researchers. Secondly, I made a brief overview of association rule mining algorithms, particularly with numerical association rule mining algorithms. But the story doesn't end here, so I must mention challenges also for the future. So nowadays we are looking for algorithms for new evaluation metrics, particularly. So we still need to find a very efficient strategies for shrinking the borders of numerical attributes in order to make more efficient, accurate results. We must develop more sophisticated fitness functions, which will take many evaluation matrices in account. testing proposed approach on bigger transaction databases also is an important goal for the future. I think we will now have some problems with in genetics field, so where we deal with very big data sets with so many genes, and we need to find here some association rules, so how different genes interact and have influence on the development on cancer. So we will definitely need to develop new evaluation metrics to deal with these data sets in genetics. We deal with the data sets where we have a lot of attributes, genes, and we have also a lot of people's data, so sequenced data that must be efficiently implemented and then solved in the fitness function. Finally, we have to ensure also the quick flow of ideas in research papers into the real world. So as I said earlier, there several algorithms exist, but still minority of these algorithms are actually transitioned from research papers to the real world or industry applications. So I personally believe that we must apply more ideas in research papers to the real world applications, to the industry. So I see a lot of potential in this argument, and I am sure that industry will take up these ideas and apply for solving their problems. So now I must say thank you for listening to me. I hope my topic was interesting for you, and I really hope that you will check some software tools that were proposed here, and I will be extremely happy to discuss with you this topic. So I invite you, if you have questions, also to send me email, and I will try to respond to you as soon as possible. I am also always interested for a cooperation in research. So if you are working in this research area, I would be happy to discuss about potential joint ideas. So yes.
Thank
so
you.
Thank you all. Yes.
Yeah, thank you very much, sir.
Yes.
I would like to thank on the behalf of Sreyas Institute because we are running short of time. So participant, if you have any query, you please mail that query to the Professor Ijok Pfister. He will reply on that mail. So I just want to tell you that the topic which is given by Professor Pfister was very impactful, and I hope the researchers who are working in this field, definitely they are going to get a good open challenges in that area. They can also collaborate with Professor Ijok Pfister, as the email ID is mentioned here. So you can write to him, and he will be happy to collaborate with you. And the topic title was a numerical association rule mining using population-based and nature-inspired algorithm for recent advances. So I once again thank to Professor Ijok Pfister Junior, and I'm looking forward to have you in my future conferences, and I'm looking forward to have a good relation with you.
Thank you. Thank you once again for your kind invitation. I am extremely happy to be the part of this conference, and I wish you good organization today.
Thank you. Thank you, sir. Thank you very much.
Thanks.
Swati ma'am?
Sir.
Can you hear me? Yeah.
Yes, yes.
Yes. Professor Ster, please stop sharing the screen. Yeah, thank you.
Thank you very much, sir. Okay, let me just take over the session. Now we have fifth keynote speech on role of enabling technologies in healthcare using AI by Dr. Pradeep Kumar Gupta from JUIT, India. I would like to take, I just would like to welcome Sir here, and I'm really happy to read out his profile. Sir is the postdoctorate from University of Pretoria, South Africa in 2015-16 from the Department of Electrical and Electronic and Computer Engineering. He's currently working as an associate professor in the Department of Computer Science and Engineering at JP University of Information Technology. He has extensive research experience in Internet of Things, cloud computing, image processing, and pattern recognition. And he's authored more than 30 research papers in the referred journals and international conferences. Dr. Gupta was the recipient of NRF KIC South Africa 2015 grant, and he received several awards and also the part of Bombay's research team for Spoken Tutorial project. Dr. Gupta is an associate editor of IEEE Access also, and he is also a guest editor of special issues from Springer and InterScience publishers. He's the member of several technical societies, and we are really blessed to have you here, sir. We welcome you for the conference, and I request sir to please take over the session.
Swati madam?
Sir.
Due to network issues, sir has disconnected. He is rejoining the
okay, sir. Okay, sir.
Yes.
Meanwhile, if any participant would like to raise any question from the previous keynote talk, they can ask.
Madam, just give a...
Sir is back.
Yeah, sir is back. I just make him as a co-host.
Yes.
Please welcome one more time.
Okay, sir.
Yeah.
Gupta, sir?
Yes, am I audible?
Yes, sir. Good afternoon, sir. We really welcome you here. It's really our honor to welcome you, sir, because we just had your profile reading and all, and it was really, really nice to meet you here. I request you to please take over the session, sir.
Thank you. Thanks, Dr. Ashwani, and thanks the management of Sreyas Engineering College, Sreyas Institute of Technology, for providing me the opportunity to be a keynote speaker at the first edition of ICAIDS. I hope this conference will make a grand success in the near future, because the title of this conference is very hot and a lot of work is being done by the researchers, scientists, and all the community of this field. And if you are the researcher and faculty members working in this domain, so you can find that a lot of papers and a lot of new technology is being innovated using the AI, using the data science. So future is totally in the hand of the data science and the AI. So thanks, Dr. Ashwani. So with this, I begin my keynote discussion. So I'm sharing the screen.
Yes, sir. Please go ahead, sir.
Yeah.
सर मिडिल यू फाइंड शेयर ऑप्शन शेयर स्क्रीन
कहाँ पर है
सर बीच में बिल्कुल बीच में ग्रीन कलर
हाँ शेयर स्क्रीन यस
शेयर स्क्रीन सर फुल प्लीज शेयर द फुल एंटायर स्क्रीन सर
ओके
राइट सर Sir, please make it presentation mode, sir. We can see it, sir.
Is it visible?
Yes, sir.
Yes,
it
sir,
is
it is
visible.
visible.
It is in
Sir,
the
please turn
presentation.
on the slideshow, sir. Full screen.
Slideshow.
Yes, sir.
Yes, sir. Slideshow, then click from beginning, sir. Near animation, yes, sir.
Okay.
From beginning, yeah.
Yeah. Is it okay?
No, sir. Actually, you have shared PPT screen. Actually, that's why it is not coming. For us, it is showing that smaller resolution. So I hope again you have to stop the sharing.
Yes, sir.
You have
Please
to stop
stop
the
sharing it, sir. Once again, reshare it, sir.
And you have to click, sir, entire screen, not PPT, full window screen, sir.
So I'm not getting option full screen full.
Sir, the moment you will click screen share, it will give you a screen. That screen you have to click and then share.
Yeah.
Yes, sir. Now perfect, sir. Perfect.
Okay.
Yeah, sir. Great, sir.
Okay, so the title of my keynote talk, it is a role of enabling technologies in healthcare. And here in the enabling technologies, I have selected the artificial intelligence. So the contents of this discussion, it is evolution of computing paradigm, then the various enabling technologies in the field of the healthcare. But basically, enabling technologies are grouped as per the domain. So if you are working in the healthcare, so you will find some set of the different enabling technologies. If you are working in agriculture, then some other set of technologies are there. So here I will the technologies that are the part of this healthcare framework. It is sensors, wireless communication, cloud-based models, fog-based models, AI-based models, and then the things which are towards the AI. So here the traditional versus predictive models, then predictive computing, and the various works that have been carried out using these technologies. So over the period of time, a lot of computing paradigm have been evolved since 1958 onwards. So I have included the details from 1958 to till today. So since 1958, the various procedural and imperative programming languages were there in the form of the Algol, Fortran, Pascals, and C variants. So from 1958 to 2011, you can say these programming languages are highly in use. Then later on, the functional programming languages have started evolving in the form of the Lisp and the Miranda. Then declarative, so things are moving. Technology is changing very rapidly. So declarative programming languages, object-oriented programming languages, scripting, parallel and concurrent and agent-based, and now the things are in the hand of the enabling technologies and the predictive computing. So this is what a gist of the various programming languages that have been evolved over the period of time, and most of you are familiar with some of the programming languages which are more common today in the form of the JavaScript or Java or C++ or Logo, Pascal, C and its variants. Yes, so these are the various common programming language. VB script is there. Erlang, some people are still working nowadays on Erlang. So these are the various programming languages and the programming paradigm that have been existing, and now some of the paradigm are still in use. So making use of those technologies, so the framework of enabling technologies have been designed. So what this overall consists, enabling technologies. So enabling technologies, as I have already said, it consists of some set of technologies in the form of the sensor technology, in the form of the wireless communication technologies, then cloud computing, big data is there in this framework. machine learning, artificial intelligence, fog computing, edge computing, and then IoT, Internet of Things. So these are the typical technologies that makes the framework for the future healthcare, or you can say the healthcare 4.0 or 5.0. So moving further, if we look at the various sensors that are available in the medical background, so for the medical field, so they vary from the measuring the temperature to measuring the oxygen levels and measuring or identifying the uh, posture of the patients or the condition of the patients. So these sensors vary. So some sensors are related to the measuring of the room temperature and the humidity levels. Some sensors are related to the measuring of the body temperatures like LM35, TMP236. So if you are going to design some thermometers, infrared thermometers and so on, so you can make use of these sensors and you can collect the results. Then heartbeat sensors are there that measures the ECG or that are used in ECG, electrocardiograms. Then sensors are also there for measuring the body fat, blood oxygen saturations, pulse rate, then body blood pressure, body position. So these are the various healthcare related sensors which are used by the researchers in their work while making the device. Then wireless communication technologies are used for communication purpose. So how the communication could be established? So the best way it is to use the Wi-Fi. Then you can use the low-level communication technologies in the form of the Bluetooth, Zigbee, and low pan. Why it is a low wave? Because they transfer the data at a slower speed in comparison to the Wi-Fi, and these technologies are used for collecting the data from the patients, the sensors which are associated with the patients in the operation room, in the hospitals. So these sensors continuously, means these technologies continuously use to collect the data from this environment, and then later on you can use the data for further its storage on the cloud by making use of the Wi-Fi technology. So where the transfer rate of is 54 Mbps or more than that, 100 Mbps nowadays, and in comparison to the slower technologies like Bluetooth that supports 1 Mbps of data transfer rate, Zigbee supports 250 kbps, and low band it supports only 50 kbps. And technology wise, topology wise, they all supports various type of topologies which are in common use. Then if we are talking about the enabling technologies and we do not discuss about the cloud based model or cloud based technology, then it is just like you can say that you have a car but you do not have a petrol. So it is a must one, because no other technology will process the data that you have collected. You can collect the data from the by using the various technology that we will see in the next further slides, 2 to 3 slides. But the major processing of that data takes place only in the clouds. So cloud servers should be efficient enough. So if you look at here in the diagram, so you have collected the various records from the patients, whether it is a respiratory rate, whether it is its pulse rate or fall detection, then central node, then gate detection, and so on. So all body movement, body temperature, and so on. So making use of the low-level technologies, you can transfer this data to the base station, and then from base station they will be transferred to the cloud for further processing. So cloud can send this data to the general practitioner or to the specialist or to the nurse or to the carer or many other you can say the health specialist, which are related or which are known to the patient. Then another technology is there in the form of the fog and edge computing models. So fog-based models. So here, if you look at, so at the bottom you have the various smart devices which are equipped with the various sensors. So these are the various sensors devices are there. The smart devices, sensor 1, 2, 3, 4, and so on. So group of sensors are there. You can have these sensors may be installed with the various patients or may be installed in the some premises of the hospitals in different rooms and so on for collection of the data. So rather than directly sending this data to the cloud, these data is collected by the various nearby devices. So these devices makes a layer, and this layer is known as a fog layer. So definitely the typical kind of processing means typical kind of processing se jo matlab hai, it means that you cannot do the data analysis. You can collect the data, you can segregate the data, and you can send this data to the nearby cloud workstations that are there, virtual machines are there, concerned databases are there. So this is what it is for the rigorous processing. So cloud makes the possible to rigorous processing of the data, whereas fog layer is just, it will just segregate the data, means where to redirect the things. Then same if you are going to deploy the AI based model, so AI based model. So AI-based model, in AI-based model, you have the various techniques, you can say, that is ML, DL, and various other technologies are there, which are the subset of the AI. So you collect the data and you find the gaps in that data, which is not visible, you can say, which is not visible to the specialist or to the researchers. So AI makes it possible to find the gaps. So how you can analyze the things, how you can find the gaps. So you apply the various models, AI-based models. So here I have taken the example of the deep learning model that analyze that data rigorously at the cloud side. So everything is there in the cloud. So you deploy these models on the clouds or in offline mode to do some predictions. So this is what is the demand, or this is what the need of the hour, that how to make this prediction possible somehow, means how to, because many times practitioners check the data, look at the data. If it is an experienced practitioner, then they can find the gaps. Okay, you should go for this analysis, you should go for this test. But if you are a novice and you have just started practicing in the field, then definitely you need these models. So these models will help you to analyze the gap before any disease could take place. So you can analyze the ECG pattern, and these patterns will be processed by these models, and they will predict what is the current position of the heart, or what is the current you can say condition of the heart, so that if there is any possibility of a nearby disease, so that could be predicted beforehand. So that's why I've said that these predictions are the need of the hour today. So moving further, if you compare the traditional model versus the predictive model, so traditional programming languages that we have seen in the first slide. So in the traditional programming, the way of programming it is that you have some data in your hand and you also have some rules in your hand. So you combine the data and the rules and you get the answer. Let's say you have the data for the various integers, and then you have applied the rules that calculate the sum of the quadratic, means calculate the given input is the quadratic equation, so you have to find the value of the x. So you have to apply the rules. You have to write the program that x is equals to 5, and now calculate the value of this polynomial. So this is what is your answer, but that you can easily get from the traditional computing model. But in predictive computing model or in predictive model, you have the data and you have the answer. So this answer is in your hand. So you apply the data and you answer, means you provide the answer. This is the answer. This is the data of the lung cancer, and this is what the images which are infected with the lung cancer, and these are the images which are of the normal patient. So you know these images are infected with the lung cancer, and you have the data. So you will provide these data and you will analyze this data and you will find the pattern. Why there is a lung cancer. So this is what you have to analyze. So you try to find the rules, you try to build the rules. So this is what the major difference in between the traditional and the traditional model computing and the predictive computing. So this predictive computing has evolved over the period of time, but it is defined recently in 2015 and 16, where the Nadin and the team of Nadin, they have described that predictive computation is the path that leads from reaction-based form of computing to the anticipatory form of computing. So reaction-based, as it is, we have discussed in case of the traditional computing model. So anticipatory, that is what is predictive computing. So what is there? So you try to predict the state from the past state. So you have the past state in the input, you have the current state in the input, and you try to find the future possible states. So this is what is function that takes the various data or you collect this data to predict the current state as well as the future states to predict the value. So the horizons of this predictive computing is all along, means all around, you can say, from smart home to transport to community to national need, then industry, policymakers, personal users, and healthcare. So these are the various uses for these domains. So if you look at the healthcare, so patient monitoring is there, emergency is there, records is there, OPD is there, and so on. So number of things are there that you can have for the various patients, those who belongs to the domain of the healthcare. So predictive computing and technologies that makes it possible. So predictive computing is a subset of the enabling technologies without which it is not possible to make the predictions. So if it is a predictive computing, then definitely you require the machine learning, you require the sensor technology in the form of the IoT, big data, and the deep learning. So these are the typical components that should be there. And definitely the cloud is all around, because finally you have to send the data that you have collected from the various patients and the hospital to the now the prediction in the healthcare. So here I will focus on the various you can say the areas in which I have worked. So prediction in healthcare. So first is the prediction in the lung cancer in humans. So a lot of work is being done by the researchers to analyze the medical data, whether it is a skin cancer data, whether it is a lung cancer data, whether it is a brain related data, whether it is any tumor related data. So lot of data sets are available. So important thing is to find the good data set to perform your experiments. So rather than looking for the data set at the local repository, either you focus on designing your own data set by collaborating some hospitals, or you can download from good universities in the US. So here the data set that is taken, it is from the UCI repository. So this data set for the lung cancer is around 11 GB in size and requires the you can say faster machines for applying the various algorithms. because these algorithms takes a lot of time when you apply on the faster machines, 1 day, 2 day, or more than that, because the size is very big. So here on the lung cancer data set that is collected from the UCI repository, so applied various algorithms like KNN, SVM, decision tree classifier, multinomial, stochastic gradient, random forest, and multi-layer perceptron. So these are the typical machine learning algorithms we have applied on the downloaded data set, and then we have checked the performance of the algorithms, which one is better and which is to be considered for detection of the lung cancer. So here the processing step or lung cancer detection system that is designed. So it is where we have acquired the various images, CT scan images. These are the CT scan images, not the X-rays. And then we have applied the various image pre-processing and segmentation techniques to improve the quality of the images and to resize the images. Then we have extracted the various features from the various segmented images, and then the image classification has been done. So this is the area where the various ML approaches have been applied, and then we have compared the performance evaluation of the various machine learning algorithms. So these images look like of lung cancer, something like this. So where we have applied the various pre-processing methods in the form of the image to remove the noise, so image denoising methods. So various filters have been applied: median blur, Gaussian blur, and bilateral blur. And then we have also applied the thresholding methods, that is global thresholding, OSU method for adaptive mean thresholding, and OSU method for adaptive Gaussian thresholding. So it is just to analyze the various images that are available in the repository. So you can apply the various other methods. So here typically the machine learning algorithms have been deployed, and then these are the results of the performance evaluation for its accuracy, for measuring the F1 score, precision, and recall. So multi-level perceptron has achieved the maximum accuracy for the given set of the lung cancer. Still work is going on. One can apply the many other algorithms of the field of the AI, that is deep learning models can be applied to achieve more performance. Then some recent work. So here in the recent work, lot of work is being done by the researchers for finding the COVID or to analyze the COVID data sets, whether the COVID is there or not. So during the lockdown, I've got the opportunity to do work, something new with the deep learning algorithms for the COVID patients. So this is what, if you look at that, it is a published work. Previous is also published work, and it was published in 2020. So at that time, so a lot of work was being done, and data set was limited for COVID patients. So it was published around in August 2020. So we have taken the data sets of the various lung images. So X-ray, we have got the X-ray images, and limited data set was there. So we have to generate the data set. So we have applied the various methods, image augmentation methods for generating the more images. So if you look at, so we have proposed this ENCOVNet framework. So in this, it is for analyzing the X-ray images of the COVID infected patients, and it focuses on observational analysis of lockdown is not only the solution and extremely required to overcome from this situation. So that is what is some artificial intelligence methods. So world was looking some intelligent methods. So we as a computer scientist, we have the tools in our hand, that is artificial intelligence, and we have tried to apply it not only at particular location. It is worldwide. People are applying. So if you look at the repository of the WHO, so WHO has provided the free repository for these publications. So a lot of publications are available from the worldwide. So here we have analyzed the X-ray images of the lung for person in order to detect the COVID. Then obtained results by using 3 different parameters known as the confusion matrix, then area under curve of ROC, then training accuracy. So we have analyzed these 3 parameters, and the results that we have obtained for the COVID positive patients, it is around accuracy 97%, and overall accuracy of the proposed model, it is 88%. So if you are getting the result somewhere 90 or above 90, so it is considered that this you can say ensure the presence of the disease is there. So as I have said, that data set was limited in size. So if you look at the parameters at that time available, nowadays a big repository is there for the data sets. You can find in the GBs in the size. So data set consists of around 192 X-ray images of COVID-19 positive patients. And total, the images that were there in the data set, it is total 337. So all the images are verified and annotated, including the findings of the X-rays. Then data sets we have. So the data sets are usme we have the various views of the lungs like posterior, anterior, PA, anterior posterior, APA, and then anterior posterior supine, and or you can also say AP supine views of the lung. So for experimentation, we have considered the posterior anterior views of the lung images during the training and the testing. So then the normal healthy patients, so we have used the Kegel chest X-ray images. It is these images that are there, it is around 5,863 images of the pneumonia patients. So these images are divided into 4 classes like normal, bacterial pneumonia, and viral pneumonia, and so on. And the normal patient, definitely. So data pre-processing. So any data that you download or any data that you are having requires some pre-processing steps, because data is not there as per your requirement as you require for your model of a processing purpose. So these pre-processing, if you compare, if you look at the previous work of the lung cancer and if you look at this work, so data pre-processing is there. Image pre-processing, it was there in the pre-processing, and here it is same image pre-processing. So you have to convert the size. So जो model आप लेने जा रहे हैं, deep learning model that you are going to implement, AI based model. So what kind of size of image it will take? So it will take. So we have converted, means we have to pre-process all the images. Means we have converted all the images in the size that is required by the proposed model. So it is 224 by 224 pixels. So all the image size has to be converted in that from the data set into the required size. Then since data set is limited, so we have applied the data augmentation. So this data augmentation techniques are there that can generate the several images on rotation basis from the existing data set. So rotation range that is there, it is around 20 that we have considered. So nowadays there is an improved technique that you can apply on the existing data set, that is known as the genetic adversarial network, GAN. So GAN is also used for generating the data sets. So that is much more faster in comparison to the data augmentation methods. So GAN is being used. So you can apply now the GAN over the existing data set to generate more images from the existing data set. So that why it is required? It is required to improve the accuracy of the results. If you are not applying the data augmentation, so it might be possible that your model gets overfit. So you will get a similar kind of accuracy, or you will get the same results again and again. So to overcome from these issues, you should have the more images in your hand, so that you can use some images for the training purpose and some images for the testing purpose of the model. So the X-ray images, so when we have applied these data augmentation methods, so X-ray images were flipped horizontally and vertically, so as to increase the diversity of the data set. So here you can find, here you can check that we have flipped the various images. We have flipped the various images. So if you look at the column 1, so if you look at the column 1, and if you go row wise, column 1, row 1, so you can find the various flipped images of the lung X-rays. So COVID-19 and other images there. So we have flipped these images in the column 3 and column 4, and same is there in row 2, row 3, and row 4. So this is how the size of the data set has been increased by flipping the images at various angles, horizontally and vertically. So that's why here, if you look at, then you will look at the title, that labeled X-rays after data augmentation. Then data leakage issue is also there. So as I just said that every time you will get that overfit, the system model is overfit, you will get the same results again and again and again. So data leakage is also one issue that will give you the same answer or same accuracy again and again. So here we have performed this by manually, by assigning 70% of the patients for training purpose and remaining 30% for the testing purpose. So 127 patients, images of the 127 patients been comprises the 70% data, and 30% comprises for the 31 patient data for testing purpose. And altogether 127 COVID-19 positive patient X-ray images for training. On contrary, 31 COVID patients X-ray for testing purpose. So this ensures that there is no data leakage among training and testing data set. So convolutional neural network, so CNN, further we have deployed at that time CNN. So now a lot more models are available at your end. AlexNet is there. AlexNet is before CNN. MobileNet is there. ResNet is there, and so on. So you can deploy these models, which are much more faster in comparison to CNN. Though I have used the CNN, but I am not in the favor of the CNN. Why it is so? Because CNN is a kind of model that requires a lot of data for training purpose. So things can be solved, things can be predicted with less data also. Why it is so? Because when I was working on this project, so I have found one model, that is a capsule network. So I've got a model capsule network that requires less data to train the model. In comparison, if CNN required 1000 images, then capsule network, with the help of the capsule network, means you require only 100 or 200 images, and that will be sufficient. So this is what the major difference is between use of CNN and the capsule network. Likewise, many other models are there. Various versions of the capsule networks are also available. And that's why I'm saying that though I've used the CNN model, but I'm not, in my future research, I've just discarded the use of the CNN model. So is it just for this purpose as I am presenting this work? So this work consists of the use of the CNN model. So I'm just describing about here, that consists of, that is a type of the artificial neural network that has multiple layers and is expert to process the high volume of data with higher accuracy and less computational cost. So the basic structure of CNN comprises various layers in the form of the convolutional layers are there, pooling layers are there, flattening layers are there, fully connected layers, softmax layer, and so on. So many layers are there. So this is shown here. typical model is shown, means where you provide the various input of the lung images to the model, CNN model architecture, where this image is processed by the various layers, like convolution layer is there, pooling layer is there, fully connected layer is there. So, and you get the result in the form of whether the image is infected, means the patient is infected with the COVID or not, or it is a normal image. So the proposed model depends on the working of the deep learning based CNN known as the ENCOVE-NET. So this is the proposed model. So the applied parameters in this models are shown here in the table on the next slide. Then these layers are part of the BGG16. So here we have used the BGG16 model, whereas in the latest version, in the another version of this work, we have used the BGG19 model. So where in BGG16 and 19, the difference of the layers is there only. And the proposed model is trained using the various images available in the image net. So size is in more than GB or terabyte, and we have achieved the accuracy of 92.7%. So this is what the various layers that are there. So input layer is there. If you look at the size of the image, so 224 by 224, as we have resized the things, and then it is passed, input image is passed through the various layers. So where there is a convolutional layers are there, max pooling layers are there, and flattening layers are there, dense layer is there, dropout layer is there, and so on. So this is what is the typical model look like. So here, if you look at, so this is what the overall model of BGG16 that we have used for experiment purpose. So we have obtained the results, as I have said, that 92.7% accuracy is there. So this is what is there. And prediction, so we have applied prediction on the proposed model. So it is able to classify COVID-19 patient correctly with 97.97 confidence. And accuracy is also there, 97.6%. So why this objective of this work? What was the objective of this work? It is to provide some better solution, because at that time RT-PCR test was there at one side, and it takes a lot of time whether the COVID patient is COVID infected or not. Nowadays, a lot of new kind of tests are available, rapid tests are available. So if we have compared the time of the RT-PCR at that time and the proposed model using the chest X-ray, so chest X-rays provide you the faster solution. Means you can say it is just 5 to 10 minutes, and RT-PCR takes 5 to 10 hours. So here, this is what the normal image of the lung and the COVID infected lung image is shown. So CXR, that is chest X-ray of COVID-19 positive patient, predictive correctly by the proposed model, and at the side B, it is the normal patient's X-ray. Then in another work, so this is what work is one of the highly cited work all around the globe. So most of the scientists have downloaded and cited this work. And this publication has achieved around 270 citations just after its publication since August 2020. And in another work, the same only thing that because at that time there was a thought that COVID-19 is nothing, it is just a kind of it is just a pneumonia and all these things. So we have tried to analyze the things with some better CNN model. So we have used the VGG19 model, and we have applied the GradChem color visualization approach on the chest X-ray, as well as we have considered here the CT scan images of the lungs. So why it is so? Because things should be clear when it is a colorful. This is what is tendency of the researcher who are working in the medical field or or those who are working with the medical images. So things should be visualized in with the color. So if you look at, so we have taken the input images of the lungs, CT scan images, and then we have passed these images through the various layers of the deep learning model. And then we have categorized or we have taken the binary decision, whether it is a COVID infected or whether it is a normal, or whether it is a COVID infected as well as it is infected with the pneumonia. And then it is COVID-19 chest X-ray and COVID-19 non-COVID-19 CT scan image. So these are what the binary outcome of the results from the proposed model. So why it is so? Why we have considered the pneumonia? जो pneumonia का data set है, the data set of the pneumonia, it is of year 2017 and 18 when the COVID was not there. So this was our prime requirement. We should use the data set during the era when the COVID was not there. So that's why we have used the pneumonia data set of that time 2017 and 18, and COVID is during the COVID time. So we have tried to analyze the things. We have tried to compare the COVID images, infected COVID images of the COVID X-rays of the patient, infected patients, and the pneumonia infected patients. So what we have found in the similarity, we have found in the similarity that it is more than 90% similarity we have found in the pneumonia and the COVID symptoms. So this work was published again in September 2020. At that time, it has not got attention of the researchers, but nowadays it is this work is much more in focus by the researchers, and it is getting a frequent citation. So this is what once the citations are there, so this improves the you can say confidence in the team, in the researchers. Yes, we are doing some good work, or we have achieved some good results. So here, if you look at that VGG19 model, so we have used the VGG19, that 19 layers are there, and then the results that are there. So we have predicted the results in the form of the normal, pneumonia, non-COVID-19, and COVID-19. So, and if you look at that, we have applied the GradeCam approach, and the input image that is there. So in the GradeCam view, if you look at, so you will found the colored image with the infected areas where the infection is there in the lungs. So you can find the dots in the GradeCam, that some red dot is there, some blue dot is there. So this shows the infected areas of the lung images. So here the various experiments have been performed. Means that in which we have considered the COVID-19 versus the normal patients data set, and pneumonia versus COVID-19, and non-COVID-19 versus COVID-19. So this is what the various experiment results of the experiments, where we have provided the images of chest X-rays, and we have applied the GradeCam image. So how infected the images are. So in black and white, it is not visible, but once you are going through the GradeCam view, so you can find the infected areas in the lungs. So same with the CT scan images of this pneumonia versus COVID-19. So in the above, A and B represents the CT scan images, whereas for the same patient, image C and D represent the chest X-ray. Then Ashwini, do we have time?
Sir, actually we have a paper presentation time from 1 onwards, sir. You already exceeded 10 minutes.
Okay, so thank you. So
we can find 2 minutes, so we can
discuss some applications of the AI-based approaches that I have applied with my team at JP University of Information Technology to do some work for the society. So at least every researcher must think about what is the contribution to the society. So we are working in the same direction to deliver some good solutions for the society. And I have discussed 2 work of recently highly cited work. And if you are more interested, then you can drop me a mail, or you can go through my Google Scholar profile to find some more work related to the AI in healthcare. So I have done some work on the breast cancer, to detection of the breast cancer, and currently I am working in the field of the brain tumor and try to find the various syndromes, ADHD syndromes, attention deficit syndromes, schizophrenia, and then Alzheimer's. So I'm working in this field nowadays. So thank you very much for paying your attention. Thank you, Dr. Ashwini.
Thank you, sir. Thank you very much. Now I would like to ask the participants if you have any query.
Yeah.
You can ask one or two query because we do not have time. Our session has to be started from 1 onwards. So one query we can entertain right now. Yes, participant, you have some queries to sir? Okay, sir. I want to ask one thing, sir. Sir, how can we overcome this overfitting if our data set is giving overfitting problem? So how can we avoid? What are the solutions for that?
Actually, overfitting is a common problem in the data set. So I will suggest that you should try to more images during the training phase, and you should try to include the dropout. So normally while performing the experiment, we do not consider the dropout. So you should try to keep out your dropout probabilities around 0.4 to 0.5. So this will ensure the better accuracy of the models, and this will ensure the issue that you face in the form of the overfitting.
Okay, sir. Thank you, sir.
Okay, sir.
Yeah, sir has given a very nice, remarkable and knowledgeable speech in the field of machine learning and artificial intelligence. What is our role in healthcare? How these emerging technologies can be used. So the presentation was very impactful, and I hope this will help the researchers who are working in this particular area. And sir has already told that you can refer the Google Scholar ID if you want to collaborate. Sir also has given the open problems also in where he is working right now. So sir, we are looking forward to associate with the JP University. Definitely. And we can exchange some FDPs, STPs, and want to. Thank you, sir. Thank you very much for sparing time, sir. Thank you.
Thank you. Thank you.
Thank you, sir.
Thank you.
Swati ma'am.
Sir. Okay, sir. I'll take over.
Yeah,
welcome back, everybody. I hope authors are already here. I would like
can
to
stop sharing your screen.
Sorry.
Just a minute, madam.
Okay, sir.
Yeah. Yeah, madam, go ahead. Sir will stop.
Okay, sir. I would like to request paper ID 145, Abdul Rahman, to please present the paper.
Abdul Rahman, can you hear us?
Yes, he unmuted himself.
Yeah.
Rahman, please share your screen.
Hello, are you hearing me?
Yes,
yeah, we can hear you.
Okay, thank you.
Swati ma'am?
Sir.
We have our session chairs. I hope we have to.
Oh yeah. Okay. Yeah. I totally forgot.
Yeah.
Okay. I'm really sorry, sir. Okay. I would like to invite the session chairs, Dr. Muhammad Amir Khusru Akhtar, sir, from Martin University, Ranchi, Jharkhand, and Dr. Pranaya Bhattacharya, Institute of Technology, Nirma University, India, and Professor Satraj Ahmad from KIET, UP. I really welcome you, sir. Welcome to the conference. Shall we start the presentation, sir?
Session chairs, please give your consent to start the presentations.
Okay. Should I start now?
Yes, sir.
Yeah, let me.
Yes.
Okay, thank you. Today's my presentation topic is detection and counting of blood cells employing deep learning and YOLO-V5 method. This is our topic. And now I would like to introduce our total outline. First of all, you all see that our total outline, introduction and problem statement. And now I would like to introduce the whole project and introduction of total part of it. We all know that in human body, we have three types of blood cells, red blood cell, white blood cell, and platelets. We all know that in red blood cell, in human body, 40 to 45% of total blood cell are red blood cell. Those we can also call it erythrocytes. And this blood cell is also important for carrying oxygen to the tissue in human body, and it also releases the carbon dioxide to lungs and exhale. And another blood cell is white blood cell, which are only 1% in human body. We also call it leukocytes. It's help to fight against the infection and other diseases. And another blood cell is platelets. Also, we can also call it thrombocytes. This is the most largest blood cell in human body, and this blood cell help to prevent about bleeding. And my next topic is problem statement. Why we chose this topic to for this research and for this analysis. We all know that blood cell counting is more important for disease, diagnose some diseases like thrombocytis and thrombocytopenia and a lot of other diseases. We all know this in this COVID pandemic. In this situation, COVID-19 is more serious situation in this time, and we all know that all COVID patients need some plasma. And this time, when we need to exchange our plasma to one to another person, that in this time we need to test our blood cell. Like we have to mismatch our total blood cell, and we have to count the blood cell. And obviously, COVID-19 patient also require counting platelet blood cell frequency. And main problem statement is counting blood cell manually is also more time consuming, and it maybe give us more low accurate result because of human can make me error. And if we use our traditional method like highly, then it can be we need more skilled person, skilled laboratorian, and we also need more high type of equipment in our laboratory. This also more most time consuming. In also we have to pay some more money for, and we also must cost massive cost in this method. But we propose an automation system for this statement. This automation can make more time saving and also more minimize our cost. And this model also maybe a high potential system, and counting blood cell is more accurately and more in more short time. Here we did some literature review. In this paper, in some literature review, I can explain Sreyas. This author approach identify the sickness and leukemia, particular acute and also acute leukemia. In this paper, they did not hit the expected outcome for the low amount of data. We all know that if we want to get more accurate result, then we need some huge amount of data. And second author also proposed an image processing and automation method for counting red blood cell. Has been developed through the huge transformation was used to extract text feature utilizing morphology and a lot of feature holding and segmentation and cell counting. But here also same method we can apply. More data makes more accurate result, but there is unfortunately there is no information about data set. And third author also approached the classifying method cell to categories, normal and pathological. The entire program is built on MATLAB image processing algorithm. They propose just blood cell detecting, white blood cell counting. They propose just blood cell detecting, but while we all know that blood cell is counting is more important for a laboratory. And the third author also developed an algorithm that performs sickle red blood cell classification test. red blood cell mapping and cell segmentation and classification automatically. This article also explained how to detect and count distinct type of blood cells from CMR image using deep learning. The method does not need binary segmentation, but they did it. And grayscale communication, this is completely automatic and precise and time-saving method. Here is our methodology, how we work and how we follow the study from workflow. First of all, we collect the data, then we process the data. And after that, we applied this data set in NOV5 algorithm. Then we detect our performance evaluation, performance analysis. We did our performance analysis. You also see our NOV5 network architecture, which we did. Here we calculate the three part of our. We calculate 3-step, follow the 3-step backbone, neck, and detection. I can shortly explain about backbone. And this model also, this model used for train, test, and compare to detection accuracy and detection speed of the CNN model. And NEC also using for ensuring that important features are not lost from this system. And finally, we detect our model, we detect our feature. After that, our methodology content. First of all, here is the procedure of our collection data and how we process the data for the training set. First of all, we collect this data from Axoilamba GitHub repository, which is online repository, but it's also authorized by MIT. And our dataset contains 366 images. Also, our dataset contains 3 types of blood cell. We all know that white blood cell, red blood cell, and platelets. We divided this dataset 50% of training, 30% of testing, and 20% of validation. And all of our annotation images are manually selected. And then after that, we convert this data from XML to text data. Here you can see that the equation of our performance evaluation. We did precision, recall, and measure mean average precision. We all I can shortly explain about precision, which is better from the precision, recall, and mean average precision. We all know that low precision is high and high recall is best for the always best for the model, and our mean average precision, which are also showing the average prediction and also total accuracy of our model. Finally, we have our result and discussion. Here is you can see our performance result of the YOLO-V5M version. Here we had this model detect 1246 cell, and this 1246 cell we have average precision 0.799 and also our average recall 0.803 and mean average precision for 0.5 it's 0.824 and also mean average precision 0.5 to 0.95 it's 0.428. Here you can see that the total platelets, red blood cell, and for white blood cell our detection. And after that, our detection result. We always see that our platelet detection result is 0.9, which 90% of platelet detection result, and also 80% of white blood cell detection result, and we always see that 80% of red blood cell detection result. And here is our visualization of the. After that, you say that here is visualization result of YOLO-V5M. Here is our conclusion and future work. Here we use the latest version of YOLO-V5 model, and which can identify and count the blood cell, real-time blood, which from real-time blood cell images. And this study proposed YOLO-V5 model performance better than YOLO-V5S, which is precision value of 0.799%. And our future work will be we will be we will update our technology and we will apply, we will collect more images and apply to this model for detecting and performing causal evaluation. And also, in future, we will try to improve our images, and also we will apply more method in this for these images. Here you can see the references from this paper. Thank you. All about it.
Okay, Rahman, thank you. I request the session chairs to please go on with the queries.
Okay. Hello, Muhammad Abdul Rahman.
Yes, sir.
I have a few questions for you. Like the first question is, what kind of sensors you have used for data collection?
Sorry, sir. Can you?
What kind of sensors you have used for data collection?
Oh, sir. It's I collect this data from the online GitHub repository.
Okay. You have not collected from sensors.
No, sir.
Okay. And the second question is, have you compared your system with any existing system?
No, sir. We will propose this system in future work. We just collected another work from this. We compared this data, YOLO v5M and YOLO v5S version.
Okay. That's from my side. Over to you, ma'am.
Okay, sir. Any more questions, sir?
So first of all, like you said that you have taken this from GitHub repository. What was that repository?
Yes, I can. This is the repository, GitHub repository, Akshay Lamba, all cells.
Okay. And it has basically your 366 images. How will you justify that these number of images would be sufficient for this much accuracy?
That's why we will propose the future work. We will collect more data and apply it.
Yeah. So now in the future work, you said that you will be collecting the data from sensors, right? Means real-time data collection you would be carrying out.
Yes, sir.
Okay. What will be the challenges in such case? Do you think it will this collected repository and the collection of the real-time sensor data, you are going to face a lot of challenges once you do that?
Yes, sir, definitely.
Yeah. So what is your strategy? How you are going to work with this thing?
Okay, sir. In this time, I just apply this kind of data set, also 366 amount of data, just apply in this YOLO v5. And we just want to see that how it's result evaluating the images. But after this research, I can understand that we have to improve the more data set, and also we have to apply this data and also collecting more data in many other algorithms.
Okay. So, secondly, what is the novelty? Means you have used the YOLO 5 version 5, right?
Yes.
What is the novelty in your work? That is, you have used a method.
Okay.
Now, what is your novelty in this work?
Okay, sir. Basically, YOLO. Okay, sir.
Yes,
basically, YOLO is the most latest version in our work, and many people apply it from some vehicle detection and some lot of others detection detection, but no one can use it for blood cell detection. I just apply it for blood cell detection. How it works? I just want to say that.
Okay, so it's just that there is that you just have to use it for a sort of an application. But what is that novelty part that I'm a little bit unsure? See, like users have used it for different applications, okay, and you have used it in healthcare application. Is that the novelty only?
Yes, sir.
Okay, thank you. That's all from my side.
Thank you.
Okay, participants, anybody would like to ask any questions?
Swati, I think we can.
Yes, sir. Yes, I'll wind it up. Yeah. Okay, thank you, Rahman. You can please stop sharing the screen. Now, I would like to call upon paper ID 147, Sajal Hussain.
Yes, ma'am.
Okay, please start sharing your screen.
Assalamu alaikum, everyone.
Yes,
I'm
yes.
Mohammad Sajid Hussain.
Yes, go on.
I'm an honors.
You'll be given 12 minutes of time, Sajal. Excuse me. You'll be given 12 minutes of time for the presentation and last 3 minutes for queries. I request you to please wind up within the stipulated time.
Okay.
So in that case, what you can do, you can just come, you can start with the introduction. Just very quickly, you complete the literature work and you can come to your model. Exactly. From there.
Okay, sir.
Okay.
Okay, sir. Okay, sir. This is Mohammad Sajid Hussain. I am an honors graduate student of Daffodil International University in Department of Computer Science and Engineering. It is an honor for me to have this opportunity to talk about our research, which title Stroke Prediction System Employing Machine Learning Approach. This is the outlines what I will explain today. Basically, stroke is a medical condition. It occurs when the blood supply to the brain is blocked or a blood vessel in the brain is burst. Stroke is the major cause of long-term disability in adults and the second leading cause of death worldwide. Stroke affect 15 million people each year. As per the World Health Organization, one person who dies every 4 to 5 minutes due to stroke. Basically, there are two main types of stroke: ischemic, which one is due to lack of blood flow, and second one is hemorrhagic. It happened due to lip bleeding. In 2013, one study says approximately 6.3 million people had an ischemic stroke and 3.4 million people had a hemorrhagic stroke. The main risk factor for stroke is high blood pressure, and uh, other risk factors are including high blood cholesterol, tobacco, smoking, obesity, and diabetes. Problem statement. It is an important proper step to. It is an important to take proper steps for a possible stroke patient within a moment. The chances of survival are greater when emergency treatment begins quickly. In one survey, most respondents, 93% recognized suddenly numbs on one side as a symptom of stroke. Only 30%, 38% were aware of all major symptoms and knew to call for emergency. It is totally quite difficulty to predict stroke within a moment, but if it can be predicted, mortality rate due to stroke can be reduced. Patients who arrived at the emergency room within 3 hours of their first symptoms often have less disability after a stroke than those who receive delay care. This issue can be solved using a well-trained machine learning model. From this perspective, the study aims to build an efficient model to predict stroke for a patient. Here is some literature review. I got for I only take 4 literature study reviews. In one study, Govindrajan and others use string manipulation and a deep learning approach to investigate a number of ML, including artificial intelligence, artificial neural network, and exploring that the approach gives the best result with a 95% success rate. I would like to go for methodologies. Here is the workflow of our study or conduct to our implementation. Now we used a dataset of Kaggle. The dataset contains 14 features with 5,110 instances, where 2,994 are females and 2,115 are male patients. Among all the individuals, 249 patients have stroke, and the remaining haven't any chances of stroke. After that pre-processing, in pre-processing part, we pre-process our data for better analytic result. In the pre-processing stage, at first, missing values are handled using mean and mode statistical method. Now we removed irrelevant features, then level encoded. Level encoding is performed for categorical features. After that, we normalize our data set because different scales value might create bias. Then we know that in our data set, there are 5,110 instances where 249 patients had stroke, and rest of the patients are free of risk. It indicates that the dataset is imbalanced, and we balanced our dataset using synthetic minority oversampling technique, in short, smooth. After that, we split our dataset for further. We apply multiple classification algorithm, random forest, decision tree, k-nearest neighbor, XGBoost, LGB boost. Random forest we use because for categories difficulties, random forest produces superior result. Its adaptability is one of its most appealing feature. After that, for performance evaluation, we create confusion matrix, draw PR curve and ROC curve, and also calculate precision recall and F1 score. Here is the result and discussion table. This table describes the performance results of all applied algorithms. From the table, it is found that XGBoost performs lower than any other classifier, where random forest and LGBoost perform the best with 95.4% and 95.63% accuracy. And both have 0.96 precision recall and F1 score. Since random forest gain better accuracy compared to LGB boost, it is highly recommended to employ random forest for stroke prediction. After that, we create ROC curve and PRC precision recall curve. Right figure the precision recall curve of all the applied machine learning algorithm. It is visualized that k-nearest neighbor covers the lowest area under ROC curve with 0.820 in values, where LGB covers the most area in terms of both area. Here we also in left figure depict the ROC curve of all the applied machine learning algorithm. It is visualized the k-nearest neighbor covers the lowest area also, and LGB and random forest got higher accuracy. After that, there is the result table. This result table compare performance of our system with other existing system. It is found here that our proposed system performs better than all the mentioned systems. From this point of view, it can be said our proposed system is highly capable of predicting stroke possibility, providing patient systems. Most importantly, patients and physicians both can use this system for better decision making and treatment regarding stroke. Conclusion and future work. Overall, the findings and the proposed models categories are below. A classification accuracy of 95.84% of random forest, and we got 95.64% for LGB boost. This model can increase awareness among people about stroke, reducing screening diagnosis cost, reducing death toll due to stroke. If I told about our future work, the future, we are trying to update our data set. We are trying to implement our model for custom data set. Furthermore, the other algorithms can be applied. Most powerful algorithms where we are trying to apply further. More upgraded techniques will be applied to increase the model efficiency. Here is the references. Thank you for hearing me.
Okay, thank you. Thank you, Hussein. May I request session chairs to please go on with the queries?
Hello.
Yes, sir.
Yeah. So can you just go back where you have talked about the proposed architecture? There was one slide where you have talked about balancing using smooth.
Yes.
Okay. So what steps have you followed at this point? Basically.
Actually, our data set is imbalanced. That's why we use smooth. Basically, smooth is working with.
So what were the how many features were there in your data set in total?
12 features.
And what is the imbalance ratio?
249 male and 249 stroke, and other rest of others are free of stroke.
Okay. Then on what basis have you considered the split percent after balancing?
We use smooth balancing. Smooth balancing, which balance our data set. It helps to split our data set in a 1:1 ratio.
Okay. See, that reason why I was asking you these questions is because the accuracy would randomly depend on these two steps, like how you go with the data set. Okay. Based on that, the performance evaluation accuracy of different models that you have considered, okay, it might vary if we change the processing and the balancing part. It is heavily dependent on these things. So how will you justify a generic behavior for this work that you have proposed? That, okay, this is like, how can you say that this is a generalized, okay, like this will perform better? Can we say it in a general manner? Whatever results?
No, we basically we apply on the real data, on the original data, but we got some poor accuracy. That's why we are try to balance our data. That's why we use the smooth.
And the papers with which you have compared, are they also using the same techniques or the same data?
No, sir.
Okay, then
they use other techniques. Can I? Yes, there is. They use other techniques, other algorithms, and other techniques.
Yeah. So means how are you going to justify this comparison again? The next question. Okay. Anyways, these are the some of the pointers. Like whenever we are doing the comparison, we should knowing that they are also using the same data set and working on different methods and techniques. That is okay, but the data set has to be the same. Then only I think the comparison is valid.
Okay, but till now we didn't find any technique to use smooth to balance their data.
That is
For
fine.
this,
I am telling about the data set, that the selection of data set has to be the same. It has to be a public data set, and the paper should have selected that public data set. That's what I was saying.
Yes. I think Dr. Pranay sir, maybe he will note these suggestions from you and he will try to incorporate in his future research, because we are running short of time. So we still have 2 presentations. Yeah.
So, yeah, we can move to the next.
Yeah, we can wind up.
Okay, sir. Thank you, sir. Yes,
can
yes.
we call the next part?
Can I call 194 Nageshwar Rao? B. Nageshwar Rao, sir. Can you hear me?
194, yes.
194 paper ID. I think he is here. Yeah.
Nageshwar.
Nageshwar 194.
Please unmute yourself. Nageshwar, can you hear me?
Nageshwar, you are in the mute. Please unmute yourself.
Madam, wait for a minute.
Okay.
Nageshwar, sir.
Yes.
Yes,
Please
yes,
go.
sir. Yes, sir. Okay, sir. Start, ma'am?
Yes. You have just 10 minutes left. Please go on.
Yes, ma'am. My name is B. Nageshwar, this is scholar. My paper title is Brain MRI Noise Reduction using Convolution Autoencoder. Now, introduction, problem statement, literature review, methodology, analysis and results, conclusion and future works. In this introduction, autoencoder is one of the commonly used approaches for denoising. With autoencoder, which is an artificial neural network mainly used to compress and decompress the data by leveraging encoders and decoders in a supervised manner. To use this autoencoder for denoising, train the encoder and decoder with noisy images as a feature and clean images as a target. The most popular techniques used in the medical field is medical imaging. Denoising, registration, reconstruction, segmentation, and comparisons are done by using the medical image processing. To solve this problem of medical imaging, over the years, various effective algorithms are formulated. In this medical image, noise occurs mainly due to the 2 phases of acquisition and during the acquisition phase, noise occurs in image for 2 reasons. The first one is due to the
Nageshwar, you are in mute again. Please unmute yourself.
Okay, madam. Okay, madam. Due to susceptible thermal noise and static randomness, emission of photon, image acquisition device induces the noise in images. In the second reason, physiological interference, it is difficult to progress the physiological process of a patient inability. So diagnosis and obtaining useful information from images, it's very difficult for doctors. Transmission noise is occurred due to the structural and statistical imaging. The problem, noise the image is unavoidable and noise removal is imperious to improve the quality of the images. Doctors use these images to make an accurate diagnosis. One of the main principal problem is noise and artificial reductions, which are naturally solved with the reconstruction techniques. Many approaches are there to address such problem, which are proposed by various researchers, and none of them is considered this artifact. This method to approach is advanced filter method or retrospective correction that take advantage of deep learning. In high-dimensional spaces and nonlinear problem, the most powerful algorithm is the deep learning-based algorithms. So it is useful for future extraction and image noise reductions. In literature review, the extensive investigation of MRI image denoising is needed because of ratio noise and intensity in homogeneity. Therefore, point of references to modify investigation, positive advances are needed to cause the imaging to show up more comparable, and this means are assigned to pre-processing. In this pre-processing step for underlining a brain MRI, incorporate the combining key steps. Registration is the process of primary arrangement of the images to typical fundamental spaces. In this methodology, the autoencoder aims to convert the input image to output image with a favor error, some errors, and it represents a linear and non-linear transformation in coding process. The major part of the autoencoder implementation are encode, code, and decoder. Encoder is it convert the original high dimensional input image to low dimensional code. Code is it feeds the compressed input to the decoder and it acts as a bridge between the encoder and the decoder. Decoder is the decoder block reestablishes the information from the code. It is the last restrictions of the original MRI images. In this figure, the proposed algorithm makes use of convolutional neural network based on ratio noise reduction using augmented autoencoder architecture, which increase the denoising performance with a boosted MRI sample image. In particular, batch normalization and residual learning are applied to enhance the noise reduction performance. In this proposed model, an encoder function is denoted G of phi, characterized phi with phi, and decoder function is represented f theta, characterized by theta. The low dimensional coded learner for input x is the code, z is equal to G of phi of x, and the re-established inverted x power I is equal to f theta G of x, G of phi x. In this result analysis, the performance measurement of the mean square error, structural similarity index measurement, and peak signal noise ratio. To add the noise, clean the image, add the noise 0.2, 0.4, 0.6 up to 0.20. Calculate the mean square error, structural similarity index measurement, peak signal noise ratio. Another comparison of the peak signal noise ratio. From this table, it can see that the proposed method for noising suppressions according to ratio noise are relatively good compared to the anisotropic diffusion filter, median minimum mean square error, total variance minimization, pre-smoothing, non-local mean. This is the comparative. This graph is represented to the comparative results. In this conclusion, deep convolution neural network based on augmented autoencoder for efficient brain MRI ratio noise suppressions, in particular batch normalization and residual learning are used to improve the noise reduction performance. To validate the proposed methodology, extensive simulation are carried out with the benchmark MRI data from the Kaggle dataset and the real-time dataset. In this future work, in this future research will be dependent on the existing this advanced autoencoder architecture for the classification of brain MRI tumor, increase the and analysis of the brain. My references.
Nageshwar.
Thank you, Nageshwar. Yeah, sir, please go on with the queries.
Nageshwar. What is your code rate?
Sir?
Code rate. Do you know code rate? You are using convolutional encoder, na?
Yes, sir. Autoencoder.
So what is your code rate?
Code
rate, not coordinate.
Code rate.
Okay, what real-time data set you have used?
Yes, sir. I have take the clean data set here. Here, input of data set, add the relation ice, and encode the convolution and encode the code here, encode decoder. Use the filters in decoder.
Okay.
Any other questions?
No question.
Okay. Thank you. Thank you, Nageshwar Rao. Please stop sharing your screen. Now, I would like to call upon paper ID 170, Rakesh Kumar.
Hello. Yes.
Yes, Rakesh Kumar. Please start sharing your screen.
Okay. Give me 1 minute.
Yes.
My screen is visible, right?
Yes, it is visible. Please turn on the slideshow.
Very good afternoon to one and all. This is Rakesh Kumar Maram from Sreyas Institution of Technologies. Now I'm going with my paper presentation. It is a smart transportation evaluation algorithm, an approach to the understanding vehicular array network. These are my outlines: introduction, literature survey, research gaps, proposal methodology, results, conclusion, and references. The smart transportation evaluation algorithm is completely based upon a computer simulation algorithm, which is most popular in the field of science in general. With computer simulation, is simulated environments, test the scientific models in order to improve the feasibility and correctness. They updated their algorithms. Today, AI machine learning is popular, able to give this rather than the real time. It is giving the simulation environment at the rate much faster than the real-time environment. Experiment conducted in the simulator medium, they will be give the results within the minutes as compared with the real-time environment. And one of the best studies using this computer simulation is the traffic network. It is more common experiment to with the network computer simulator environment because of experiment is in the not in taken in the real time. Here a problem statement is I got the accuracy of the previous proposal methodology. Proposal logic is compared as mostly work on inaccurate data. The data and inputs that they're taking the conditions for each and every conditions. They're taking the inputs. That's why it's taken in. I mentioned like inaccurate data and inputs. There is no single approaches to solve the fuzzy problems or using fuzzy logic. As a result, many of solutions arise as practical problems. That's why I'm a little confusing. And due to inaccuracy, they are not always widely accepted. And I'm going to literature work. What I did. They basically these three authors are my base papers. Here the first one, Harshavardhan Mandavina, is proposed with methodologies like fuzzy logic, based on fuzzy logic and genetic algorithms, which is a data set. They take in the data sets on number of vehicles and speed of vehicles. They are completely taking like an conditions based action. They are proposed by the condition taking proposal algorithm. And the second author is a Kaushik Andhari. Is like the same fuzzy logic, and it is an end-to-end delay. With us, they are taking the data sets of speed of parameters, and based on innovative approaches, need to ensure the efficient transport. There and third one is Komal Mehta, is of is also taking the fuzzy logic and BFO and zone-based routing algorithms. And the data set is the node velocity and the road performance. And here my proposed methodology is a complete Q learning based algorithm. Here the Q means the quality in the representative, so taking action, gaining the some future rewards. Is taking the action, gaining the best reward at the taking the action at the futures. The quality is offset the in of the policy is using the reinforcement learning algorithm to find the best action, either taking the future rewards. We're taking the finding the best action to take the rewards at the future states. It is a consider the observer policy. Q learning algorithm function learns action outside the current policy, taking the random actions. And there is a policy in here. More popular Q learning seeks to learn the policy maximize the total rewards. It gives the maximum rewards to the environment. Here, the flowchart is needed. Is start when the start of the program. Load the necessary modules. There is Python modules and load the summons. So I am using environment like Sumo environment, Sumo framework, and load the Sumo configurations and load all the GUI to the users. Start the simulation and then simulation learning the machine learning with the machine learning and show the output to the users and again pass it to the environment and environment again pass it to the machine learning. It is a completely rotational type algorithm. Here the take an example like when the agent take an actions on the environment with the state with the get the reward of or whenever if the agent is taken action with positively it get the reward, otherwise it is state environment gives us a penalty to the agent. Like here basic three steps are following that. First step is the agent state the start taking the state in action A1 and receive the reward R1. Or else it is if it is not taken, it is taken punishment to the environment. Agent select the random actions referring with the Q table with I max value or random value by epsilon, which is considered with the epsilon, and update the Q values. Here there are three basic steps following this algorithm. The update the Q value for the Q learning algorithm is update the Q values are Q state and action of the new values equal to the present state is equal to the Q state of the old previous with alpha value. Alpha is the learning rate of this algorithm and get the rewards and plus a gamma value. Gamma which is I take into the 0 to 1 and the max value of Q new state all the actions minus Q state of the old actions. Here the gamma values are means taken as 0 to 1. Here 0 means exploitation and 1 means exploring. Here the creating the Q table which is like taking values to the environment. It is completely depends upon the epsilon value. Take the states of the action and give state to the environment with the Q with the help of the Q values and take an action. Again we update the Q values. Taking the actions depends upon the two types, which is exploring and exploiting. Exploring is exploitation is means the gamma value is 0. When the agent takes first one agent takes an referring with the Q table with the possible max value of the those actions, like what is the maximum getting the Q value from the referring the Q table, then only agent will take the action with the help of the Q table. This is called the exploiting. And second way is to the action is like random value randomly. This is called as the exploring. The instead of selecting the all the instead of taking all the max value future reward, we take a certain random value. The action randomly is important because of all some agent explore and discover their new states. Otherwise, may not be selected during the exploring process. You can balance the exploring and exploding with the help of the epsilon value. And setting the values of the how can you want to explore and expect. Here some rough codes I am using, that is a epsilon value is taken as a 0.2 values, which is balancing the exploring and exploiting the value of this value to improve to the or take the action in the environment. It is randomly taken action and maximum values to the result, improve the results of the this algorithm. Here the result I am using the real sumo environment algorithm. Sumo environment. It is an open source algorithm to get the all the data sets of the vehicles, roads, and intersection of roads. All the I get from the sumo environment. This is the results where what I did. Vehicles are moving from one side to another side with a limited with a less waiting time of the intersection of roads and the crossing of the people from one side to another
Rakesh,
side.
sorry to interrupt you.
Sorry.
Wind up within 1 minute, huh? Because we have.
Yeah. Okay. Yeah, these are output values with the different delays I'm using. These are the parameters I got the this algorithm with compared with the previous one. The values are more accurate with this algorithm, and this is the graph with the total waiting time is decreases with the total vehicles are increases with the help of with that total time is decreases the intersection of roads. And the conclusion is with the help of this reinforcement algorithm, agent is minimizing the waiting time at the roads, and people will talk in at the roads from one side to another side. And more advanced is like to transport the vehicles from one side to another side with quickly. There is no disturbance with the roads. Here are the references I followed, and thank you for this. Thank you for this.
Yeah. Thank you, Rakesh. Swati ma'am.
Yes, sir. Yes,
Yeah,
sir.
we can bind up here. You can just proceed.
Okay, sir. Thank you, Rakesh. Please stop sharing your screen first.
Thank you so much.
Okay. We thank all the session chairs, Dr. Muhammad Amir Khusru Akhtar from Usha Martin University, Ranchi, Jharkhand, India. Dr. Pranaya Bhattacharya from Institute of Technology, Nima University, India. And Professor Satraj Ahmad from KIET UP for gracing the occasion and gracing the session. I thank all the authors and participants for their contribution to the conference. Kindly note that the certificate will be sent to you to your mail ID within 2 days. Thank you very much. I request Ashwani Kumar sir to please take over the session and distribute the rooms.
Yes. Dear participants, we right now we have 2 parallel rooms. So this link will be activated for both rooms. So we are going to shift it. Our session chair, Professor Dr. Anupam Singh, Professor Verma, Sanjeev Kumar sir in room 1, and remaining all the participants, you have to be there in this current link. So this will be led by Swati madam, and room 1 will be led by Dr. B. Viksho. So session 8 has to, all the participants of session 8, they has to move to the room 1. If you have not yet moved, please raise your hand. We'll move you in the second room. I think it's done. Mayank sir, we can proceed. You can create the room, sir.
Sir, I should be dealing with room 2, right?
No, you are here, madam. You will be here.
Okay, sir.
You have to run a show from here.
Okay.
Madam, you can start session 7. Just see whether all the session chairs has arrived. Uma Maheshwar, Dr. G. Uma Maheshwar. Dr. G. Uma Maheshwar, can you hear us? Okay.
Sorry, sir. That is Ph.D. College of Technology.
Yes.
Sanjeev sir has not joined, sir, still. Pavan Venu sir has also not joined.
No, madam, actually Pavan sir and Anupam sir, they have joined room 1, I guess.
Yes.
Yeah. Anupam sir, Sanjeev sir and Pavan sir, they have joined in room 1.
Okay.
Yeah. Here, I think a little
Maheshwar sir.
Yeah, little swapping is there. So Uma Maheshwari sir and Nandan Kumar and Professor Vikas Goyal are there in this current room.
Oh, yeah.
Yeah, I can see Dr. Nanda Kumar is here. I can see Uma sir also, I guess. Uma Maheshwari sir.
Sure, sir. I didn't see it, sir.
No, she is not there.
Maheshwari sir, ma'am is not there.
Okay. Do we have Vikas Goyal with us?
Yes, Vikas sir is here.
Yes, sir. I'm here.
Right. Madam, we can go for this. I'll talk to Uma Maheshwari madam once.
Okay,
You
sir.
can welcome to Nanda sir and Vikas Goyal sir. You can start the session.
Right, sir. Okay. Very good afternoon, everybody. Here we have the session chairs, Dr. Uma Maheshwari ma'am from Ph.D. College of Technology, Coimbatore, India. Dr. V.A. Oh my God. Okay, one second.
Diksham, have you shifted to
Dr.
room?
Nanda Kumar sir from Srinidhi Institute of Science and Technology, and Professor Vikas Goyal sir is also here with us. We welcome you, sir, for this session. Shall we begin the session, sir, with the participation?
Thank you, ma'am. Thank you very much. Yes, ma'am. You can start.
Okay. I would like to request a participant paper ID 176, Ruchin Gupta. Ruchin Gupta, can you hear me? Okay, we'll move on to the next one. 180, Venkata Mahalakshmi.
Yes, ma'am. I'm here.
Okay, Mahalakshmi, can you please start your presentation?
Yes, ma'am.
Yes, you can see the screen. Please turn on the slideshow. Okay. Yes, please carry on. You'll be given with 12 minutes plus 3 minutes of query time. Please remember it and then continue.
Good afternoon to one and all. So my name is Mahalakshmi.
Your voice is kind of less, Venkat Mahalakshmi. Can you please increase your volume from your end?
Yes, ma'am.
Excuse me, where is session 7? But what room is session 7?
Session 7 is in room 1, sir.
Is this room 1?
No. This is room 2.
How can I go to room 1?
1 second, sir. We'll send you a request. Please join that one, okay?
Dear author, just be for 1 minute. We are going to shift it. You are not supposed to do anything. You will receive a request to join, then you can join. We are moving, right?
Okay. Mahalakshmi, please continue.
Yes, ma'am. Ma'am, am I audible? Yes, ma'am.
Can you increase a little more from your end?
It is 100%.
Okay, please continue, Mahalakshmi. Please turn on the slideshow and then continue. Mahalakshmi, can you hear me?
Yes, ma'am.
Continue it.
Good afternoon to everyone. So my name is Mahalakshmi. I'm from NIT Srinagar. So here I'm presenting the paper titled an 8-layer MLP network for detection of the cardiac arrest at every stage of the disease. So here, these are the contents I'm going to cover. Introduction, key issues addressed in this paper, literature of methodology, analysis and results, conclusion and future work. So here, most of the people in the world are facing the disease, that is the heart disease. This is the topmost disease that most of the people are facing. So that's why I have taken this problem into this consideration. So here, by automation of this, the healthcare industry is very important for us, because to find out any disease by manual, it is an increase in the it causes the more time complexity. So here, the major reason that needs attention from time to time heart attacks is by using the traditional methods, it may take the most time. For example, to check the manually, if you want to check any disease, for example, whenever we are considering any particular patient, so manually we need to go to the hospital, and doctor may check with something by examining the physically they may examine, or by considering any lab test like that. It may take some time. For example, here, whenever we are simulating the same thing by using any machine learning algorithms, it is very easy to analyze. And it is also, in less time, we may get the result also. So here, there are so many algorithms previously proposed by the most of the researchers, but most of the researchers are addressed using only some random forest ensemble mechanism and SVM algorithms. They use the most of the traditional algorithms. But there are some more disadvantages in the existing algorithms. So here I'm going to use the multi-layer perceptron with some greedy genetic algorithm. So here I have selected the greedy genetic algorithm for feature selection also, because in every disease, not only in particular disease, not all the features are important to find out or to predict the final disease. So because that's why here I am selecting only the important features which are more contributed to find out the disease. So here I have used the multi-layer perceptron and greedy genetic algorithm to find out the best subset of features. So here key issues addressed in this paper is the data normalization and transformation, and the second one is the feature selection. So there are some missing values are there. I have replaced the missing values by using the mean and Boolean, depends upon the features. And another key issue addressed here is the feature selection. And here I have used the greedy genetic algorithm for the feature selection. And these are some of the literature survey papers I have reviewed. And most of the researchers are addressed or used only the traditional machine learning algorithms, and they have not at all achieved the good accuracy, because in the medical field, we need 100% accuracy, not exactly 100%. It must be more accurate because it is a life. That's why there may be some accuracy issues or the computational complexity issues. To address that problem, here I have proposed a methodology. The first one is the genetic algorithm. By using this greedy genetic algorithm, I have found out the most subset of features which contributes to find out the heart disease. And after selecting the subset of the features by using the greedy genetic algorithm, I have used the MLP classifier to train. So here I have developed my own model for the MLP classifier. I have used the 8 layers. Whenever we are increasing the more layers, so here it is giving the more accuracy. So for this problem, I have found that 8-layer MLP architecture gives the highest accuracy for me. So here I have used the new weight equals to volt rate plus learning rate into original value minus predict value plus bias. Here this formula is used to update the weights. And this is the pseudocode for the greedy genetic algorithm. So initially I have initialized the population with the random values. After that, I have calculated the entropy for each and every attribute. So after calculating the entropy, I have set some probability. If the probability of that particular entropy feature value is greater than that probability, I have considered that feature is a good feature. Otherwise, I have removed that one. So here for this greedy genetic algorithm, entropy is my fitness function. So for each and every iteration, I have calculated the entropy for entropy. So based on that entropy value, we can decide whether we need to consider that one or we need not. And this is the proposed 8-layer MLP architecture. So in the first layer, this is the input layer, and have used the remaining hidden layers, and finally the final one is the output layer. And by using this algorithm, I have found that only 7 features plays the important role, which contributes more to identify the heart disease. That's why I have given only the 7 subset of features to the MLP classifier. It gives the best result by using my developed model. So I got the 97.2 accuracy when compared with the existing algorithms. So these are the performance metrics: accuracy, recall, precision, F1 score, and accuracy I have considered. So this is the conclusion. We may develop any other algorithm also in. Okay, so by using my developed model, I got the 97.2 accuracy. So here the features are decreased and also the computational time also decreased, and I have achieved the highest accuracy than the existing models. So in the future, we may develop any nonlinear functions, and it may be embedded with some hypertuning, because I have not at all used the hypertuning parameters in the MLP classifier. So in the future, we may use any optimization algorithm to tune the hyperparameters in the multi-layer perceptron.
Okay, okay, Mahalakshmi, that was good. I request session chairs, if you have any queries, please ask the questions.
Swati ma'am.
Yes, sir.
Anupam Singh this side. Hello.
Sir, Anupam sir.
Yes, ma'am. Actually, I was supposed to be in session number 1. I think so.
Okay.
It is not shifted yet. I'm waiting for the room change.
Oh my God. Okay. Let me just inquire with sir.
Yeah.
Otherwise, sir, shall we continue with this room with Anupam Singh, sir?
Yeah. You can continue, madam. No issue.
Sir, you can just stay back here, sir. Not an issue.
Okay.
Okay. Sir, if you have any queries, please, you can ask, sir.
Okay, Mahalakshmi.
Yes, sir.
You have submitted 97.02, your accuracy.
Yes, sir.
So, just tell me the parameters on which you have decided. How many parameters are there? In terms of count, number of parameters, 7.
Number of layers, sir. What?
Oh, how many
Sir, I didn't
parameters?
understand.
How many parameters are there? Layers is one thing. Parameters.
Yeah. So number of hidden layers, number of neurons in each and every layer, learning rate.
No, Mahalakshmi. Sir is asking about accuracy. How many? So you have taken accuracy here, right? Accuracy,
yes,
recall,
yes.
precision, and also sir is asking about it.
Okay. Sir, here I have considered accuracy, recall, precision, F1 score, accuracy, AUC score.
Okay, so the accuracy on 8-layered MLP is 97.02. That is your finding.
Yeah. Yes, sir.
Have you changed the number of layers in your procedure, or just followed from somewhere?
Yes, no, sir. I have compared with first of all, I have used it for 1 layer. After that, I have increased the second layer. Like that, I have improved. So whenever I developed with the 8-layer fixed, so that I got the highest accuracy. That's why this is the best model for prediction.
So can you please showcase the data set with the 1 layer?
Sir?
The data with 1 layer. You said no, I had started with 1 layer.
1 layer in the sense 1 hidden layer, sir.
Okay. Thank you.
1 input layer, output layer you fix it.
Got it. Okay, thank you.
Okay. Anybody else wants to ask any questions?
Vikas Goel this side.
Sir.
Yeah. Mahalakshmi,
yes.
Have you compared your result with another paper?
Yes, sir. These are the another in the literature survey, sir. I had used the comparison.
No, that is a literature survey. But have you compared your result with
yes,
with another paper?
Yes, sir.
Yeah, show me that comparison.
Sir, here these are the existing papers only. So because I have used navigation classifier decision tree J48 database in my paper, and I have also compared with the existing algorithms. So because in the last column this is the accuracy, sir. So I got the best accuracy when compared with the existing papers.
Just move on to the your results.
Okay.
Yeah.
Okay, sir. Any more questions, sir?
Swati madam, Nandakumar is here.
Thank you.
Sir.
Mahalashmi madam.
Yes, sir.
Have you checked with different data sets or one type data sets?
No, sir. One data set. Because the title is the prediction of the heart disease.
Okay. How many users you are checked with?
Means, sir, I
How
don't
many
understand.
users? Have you applied for
How
only
many?
one type of age or different ages?
No, sir. This data set contains the all ages. Not
Okay,
only
data sets. How many users data you are taking in the data sets?
so in this data set, I have 303 samples with the 13 features.
303.
Yes, sir.
303.
Yes, sir.
Okay. Thank you.
Okay. Mahalakshmi, I have a question actually. 303 images is the
Not images, ma'am. No, not images. It is in numerical data.
What is it?
It is in numerical data, ma'am, not images.
Numerical data. Okay.
Yeah.
Okay. Mahalakshmi, you can stop sharing your screen. Thank you. May I know Ruchin Gupta? Can you hear me, Ruchin Gupta?
Madam, Ruchin has not joined. We can call next 83.
Okay, 183. Which one, sir?
Paper ID 183. She is there. Olina.
183.
Olina.
I'm here. Yes, I'm hear you. I'm listening you. Hello, everyone. I'm very happy to participate in your conference. So, can I start?
Yes, please go ahead.
Okay. Can you see my screen?
Yes, ma'am. Please carry on.
Okay, so I think I can start. Hello, everyone. I am really very happy to see you. And first, I want to say many thanks for organization and for invitation to this conference. My topic in calculation methods of economical mode of integration electrical power system. Our scientific team consists from Vladislav Kuchansky.
Excuse me, Alina. Can you please keep your screen in full screen? Please start sharing your screen. Like put it in full screen mode.
You see my screen or no?
I can see, but it is in full. See, please turn on your slideshow option.
Yeah. I check 1 minute, please. So I am restart. Maybe it will be okay. Now.
Turn on the slideshow. Yeah, from the beginning. That's it.
Super. Now, are you see my screen? Good.
No.
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 Okay. Please. I try one time more. Now?
Yeah.
Now it is.
Now perfect.
Okay. Super. So our scientific work, our scientific team consists from 4 persons. Vladislav Kuchansky from Kyiv, Ukraine, me, Elena Rubanenko from Vinnytsia, Ukraine, and also a good, nice colleague from the Hyderabad college in Sri Lakshmi Gundababu from India. So our scientific research entitled Calculation Method of Economical Mode of Integrated Electrical Power System. Our research consists from the 5 parts in first, introduction, where we research some exist results. Second, the problem of mathematical modeling of stationary modes of electrical system. Third, its parametric optimization of the operation modes of the main electrical network according to the criterion of active power losses. Results and conclusion. Attention is paid to modern methods for calculation the steady-state modes of electrical network. Science, they are the basis of all applied optimization algorithms. The paper, what we presented, also consider methods for calculation the operation modes of complexly closed electrical network. One of the most effective measures aimed at improving the technical and economic performance of the electrical network in the optimization of the reactive power mode. This parameter is inexorable linked with stress levels. So these criteria are considered together. Methods for optimizing the steady-state mode of electrical power system can be classified depending on which connection are taken into account. So our paper, our research discussed the optimization of operation modes through the use of controlled reactive power compensation device. We made all calculation from for scheme of electrical grid, which consists from 9 nodes. Here you can see all load and all power flows through all transmission lines. The problem of mathematical modeling of stationary modes of electrical system in generalized statement. The initial basic part of considered algorithms for calculating the integral characteristic and optimal compensation of reactive power are the algorithms for calculating the steady-state stationary electrical power system modes. This task has been most thoroughly worked out and brought to high theoretical level and broad practical implementation by the work of many generations of domestic and foreign researchers and practitioners of the second half of the 20th century, and a scientific problem formulated back in the 15th in general. It should be considered a state as resolved. So it's really very actual and relevant task which can be decided. Also, if you want to compensate bad influence reactive power flows, so we can to also use some power safety technology. So it means if we decrease influence power flows, reactive power flows, it means we can to decrease power losses. So for this, we must very correctly to formulate all tasks. The formulation of this essence of the task is briefly presented below. So you can see matrix form, vector forms, where Y is a matrix of proper and mutual nodal conduction, the order of which for a network of n nodes is equal n minus 1. If you speak about voltage and current, it means a vector or columns of nodal voltage are driving of order n. And in the complex element is equation 1 is divided laid down on real and imaginary components that form equation of contours from 1. We can go over the system in second equation which real numbers. Okay, if you speak the equation 1 is a matrix when consists of 4 blocks in size n to n, of which A active, G, and reactive, B, conductivity nodes and branch the network. So, regarding elements and equations of that, the balance equation for active and reactive currents in 2, for all network nodes were written in pairs. We obtain a system equation with a matrix of coefficient Y consists of block of the second order 2 and 2. So, if you speak about this equation system, is everything okay? It's work when we have square matrix. If we have like not square and other, it means we have more elements what we manage to calculate than equation, we can to have problem. This form is writing the nodal equation as will be seen from what follows is preferable. Simulation of symmetric operation mode model 2 is performed in single phase equation of three-phase network based nodal equation in the form of power balance. Nodal equation in the form of power balance have the form this, and it's like general form. Okay, everyone is, I think, knows Jacobian matrix, and we can use it here to solve nonlinear nodal equation in form as power balance predominant Newton method. Find implication. It's like just interaction method for calculating power system. So power system equation. Solution for this is found as a result of successful approximation. At each step of the iteration process, a linearized system is complied of solid equation for correction to moduli and Angel's voltage vectors and network nodes. So how it can be presented general forms, and also we can to use these forms if it's necessary. So Jacobi matrix consists of 4 big blocks. You can see it here. The element of which as a partial derivatives of the imbalance of active power and reactive power of the power in the node by the modules and angles in the nodal voltage, and also is the losses voltage losses dr angle is correction of modules and angles of nodal stresses. So here this slide presented some equation which can be used if you want to calculation or if you want to estimate current like voltage, power short circuit. It's without load power losses, short circuit, and also the total losses of active power with such voltage regulation. Because you know that if we want to have normal regimes, we must do all the time regulation, voltage, power, and other parameters. Okay, here I presented some results of calculations, the sum of total capacities of the beginning of all lines depending from the balancing power point. So it presented here, we calculated total power, so it's measurement in megawatt. And here I presented the results of calculations, the mode of operation of the network in the second iteration. So we use every iteration if you want to have optimal power, we take to account condition with some restriction. So, conclusion, the best option for optimizing the operation mode of the urban distributed system is to optimize the inter-network schemes, direct accounting of all nodes and branches including the scheme. However, given the complexity of the configuration, a significant change in the load by nodes, as well as to the presence of a large number of network division points, it's more expedient to single out the separate power supply section in the complete circuit and optimize the operation mode of this section. The complete power supply scheme can be represented as a set of included in the schemes. It's like we must to calculate separately but take to account everything. This by optimizing the operation mode of individual section of the circuit, it is possible to achieve and optimize an inter-distribution network. With the mode general approach, the parameters of the mode, the power in the system are calculated with the alternate transfer of the network division point to all the nodes of the system. This approach does not take into account the peculiarities of urban network, namely the presence of large number of nodes and branches, the complexity of the network configuration, the ramification of the power supply circuit. When all the necessary conditions for calculation the power and parameters of the operation mode are met, the calculated path turned out to be too cumbersome. The result obtained if the course of calculation do not provide useful information. Thus, it is necessary to develop an algorithm for allocation and optimize section in order to simplify or accelerate the process of optimizing the operation mode of urban distribution networks. So we think our research have future and have new problems and new issues that we must decide because renewable energy sources installed in distributed power grid, so it means give us new tasks and new issues to decide. Thank you, sir, thank you for your attention. If you have any question, you can ask me.
Thank you, Elena. I request the session chairs to please carry on with the queries.
Elena.
Yeah.
Anupam Singh this side. Have you submitted any concrete data, any result that you have?
Repeat please, because I'm not hearing you.
My query is, have you submitted some result set that you have found?
Yeah.
In the last line of conclusion, you have mentioned that that information is meaningless. Just show me the last page of conclusion. Just show the last page of conclusion.
Yes.
Last here. Yeah. So you have mentioned that yes.
Yeah. I see. Yeah.
Yeah. So, not provide useful information.
Okay. I must to explain this.
Yeah.
We speak about that really when we try to use, we produce a lot of calculation. So it's not all result calculation must to be taken into account. We must to optimize set information, and also we must to optimize step calculation. If we how to say correct, we have a lot of information, but this it try to calculate like 5, 7, 8 iteration, but it's not necessary to analyze everything. We must only to find optimal
Okay, I got your
result.
point. I got your point. Here you're claiming like you're not going for optimization, that may be for future, right?
Yeah. Yes.
Optimization is not done yet for the work.
Yes, I must explain this also. If we speak about reactive power, and in this research it's about how to correct compensate influence reactive power, bad influence reactive power. So we have a lot of research. If we speak about high voltage, it means 330 kV, but we really didn't have a lot of research in 10 kV. It means middle or low power, because and this problem before we didn't come to decide, and not necessary to decide because we don't have very big reactive power losses. But
okay,
when we
got
start
it.
to use,
Got it. Thank you from my side.
Thank you so much. And I can to start second presentation.
Yeah, you can go ahead. Yes.
Okay.
Yes, please
Super.
finish as 10 minutes as possible.
10 minutes. I have just 10 minutes. Okay. Yeah, I must make this as soon as possible. Okay. So my next presentation entitled Blockchain and Climate Smart Agriculture Technologies in Agri-Food Security System.
Alina, please share your presentation, please.
Oh, I am not. You don't see my presentation?
No, it was.
No, we can see your still old presentation. You can close it, and again you have to reshare, I guess.
Yeah. And now you see?
No.
No. No.
No.
No.
Now
Yes.
it's visible. Now it's visible.
Yes.
Yeah. Now we can see.
Yes, everyone to see my presentation?
Yes. Yes.
Super, 1 minute, please. I must. Okay, so my next presentation about blockchain and climate smart agriculture. So technology in agri-food security system. Are you see my presentation?
Slideshow, please.
Yeah, we can see. You have to make it full mode.
Okay.
Mode. Yeah.
So the most common risk in the agri-food security system are the lack of financial resources and unpredictability of natural and climate change. There are three most significant barriers to saturation of the economic system of the agrarian sector with financial resources. So, inadequate institutional environment, impact of agricultural risk, and high transaction costs. Features of the production process in agriculture and its complexity require careful analysis, assessment, and development of the method aimed to neutralize the specified and generalized risks and through of the agri-food security system. So, our work consists from the part introduction, agri-food supply chain, innovation finance mechanism, climate smart agriculture, blockchain technology in climate smart agriculture, and conclusion. So the main goal of the paper is examines the blockchain technology application of agri-food supply chain, innovation finance, agriculture insurance, climate smart farming of both theoretical and practical perspectives. So you can how it's presented, blockchain technology take to account expansion of economic function of the value chain and first level and additive value formation, second level of additive value formation, it means the productivity improvement and sit in the futures consulting
Alina,
service.
we are still we are just seeing only the first screen of your presentation. Did you change
it? And now you can see. Yes, you see, it's my second. Now I speak about.
No, we can't see that one. Please
Paulina,
stop it. We can do it again. Otherwise.
Okay, I think
yeah, this is okay.
Now it's okay.
Do one thing. You can stop sharing and then again reshare. It will work.
I think it will be okay. I try to.
Yes. You can again share.
Okay, now are you see?
Yeah, you can make it now full mode. Yes, from here.
And second, you see also. Okay, so I'm prolonged. Blockchain technology implementation helps to build a transparent relationship between consumers and producers, translating through the consumer products detailed information about individual products and each transaction in the blockchain. The proposed strategy, value added multiplier 2+. It is a strategy based on the analysis of the value added chain development by Michelle Porter and creation of an agri-food integration cluster base is presented in this picture. So you can see this. The strategy involves stimulation of participants and investment in economic activity of all agri-food value chain participants, enterprises and organizing of higher research and development certified seeds, high yield variety, farming system, and so on. If you speak about medium, it's processing and use of value added, and lower is packing, food safety, branding, target markets, IT, and so on. Segment of the value chain. Thus, the first plus of increase in value added will occur due to the productivity improvement as a result of improving the system of supply of the means of production, supplies of high quality seeds, irrigation system, fertilizers, mechanization, while the second plus increase in value added will be the result of expansion and deepening of economic function in various strategic segments of the supply chain. So it's everything presented in this figure with the help of blockchain technology. So blockchain technology is some universal technology. Okay, in this slide you can see is the mode of the innovation agrarian ecosystem as the basis of logistic integration, and the aim of the paper main goal object to examine the blockchain technology application of the agri-food supply chain, innovation, finance, agriculture, insurance, climate, smart farming for both theoretical and practical perspectives. Blockchain technology universal because allows tracking information in the food supply chain and thus improves food safety. It provides a secure way to store and manage data that facilitates the development of use of data-driven innovation for smart agriculture and smart index-based agricultural insurance. In addition, it can reduce transaction costs, which will help farmers access markets and create new income streams. So, innovation finance mechanism in CSA is to use public-private partnerships and innovation and investment mechanism to attract additional funding to the implementation of CSA technology, including concession agreement to neutralize risk and help balance investment profiles according to the level of risk. Second, identify effective tools for channeling climate finance of agriculture, providing direct links between financial institutions of SMEs. And third is to form necessary potential for the maximum expansion of source of financial and climate technology. So, implementation of the proposed strategy at the state level will improve the physical infrastructure and function of the markets in order to obtain the scale effects in the agrarian sector due to the attraction investment in agro-industrial complex within the territorial production system of the region through the development of economical corridors, and so on. So, considering the need to raise additional capital to address the challenges posed by climate change and the low level of funding for the agrarian sector development can only increase lack of funds. To ensure the access to SME finance barriers in Greek agricultural lending need to be removed, which build direct the cash flows provided to the financial climate technology directly to farmers and SME. It is necessary to apply innovation ways of attraction additional capital to the agricultural sector, both at state level and in the private sector.
Olena,
Yes.
Your first page is visible. We cannot see your complete PPT. So better to start with the full mode. It should be complete screen should be visible to us in PowerPoint presentation mode.
Okay, I can to stop and start
No,
one time more.
You can start with the first page, then go page by page in PPT form.
Yeah. And now, are you seeing my PPT or no?
Start from beginning. Start from beginning. Yes.
Now
Then,
it's I start. Yes, second slide. You see?
yes, now it is visible. Now it is visible. Then accordingly, what you are saying that should match with the content.
Okay. Now it's okay.
Yes,
So
it is
in
okay.
this slide, in this slide, you can find the blockchain technology and say, see here presented in data and information is product service and have its work and in financial support and product in financial. How is blockchains? We have in platforms and Ethereum, Hyperledger, proof of works and proof of stake, and practical Byzantine fault tolerance. So in here in this table, in this picture, you can see in some acronyms, and this acronyms correspond with the type and with mechanism what you choose if you want to use the blockchain technology in CSK. If you speak about consortium, private, and public, it's three points which can be used. So if you speak about consortium, it means formed by a group of members controlling this blockchain. Verified and added records of the blockchain is based on a consequence mechanism by a pre-selected set of nodes. So, example is regulatory relation decision making. If you speak about private, it's controlled by a centralized entity. Only people with specified authentication and permission can be part of this network and terribly can verify the other record to the blockchain. In easy example, a permissioned ledger between banks to settle interbank fund transfer and supply chain, which will be defined roles for all actors. And public is mostly public or permissionless blockchain are decentralized and are visible to the public. Anyone can join or easily leave the blockchain, and everyone can verify and append transaction to the blockchain. If you speak about example, it can be timestamping, trading of renewable energy, or so on. So here presented application of blockchain technology in CSA, and we want to speak about like some part of them. If you speak about agriculture, insurance and index insurance based on smart contracts can automate and greatly simplify the process, cerebral facilitation, instant payouts, and insurance in the case of adverse weather incident. Automatic data feeds provide continuous and reliable hyperlogical data to the contact cerebral elimination need for on-site claim assessment by the surveyor. Or if you speak about land registration, its blockchain-based implementation could provide an incorruptible ledger of land records, especially in the case of the rural poor. If this is linked effectively to VH and ED on digital IDs and safekeep of land record, in times natural disasters or wars would not be an issue, and so on, so on. I don't worry. If you speak about renewable energy, working on open sources, so it's scalable blockchain platform that would provide a digital infrastructure for energy solutions that allows decentralized selling and buying of renewable energy. It's like energy cooperatives or something more. So thank you for your attention, and if you have any question, I can answer, because I think I spent all my 10 minutes.
Olena, just go to the conclusion page.
Okay, if you will speak about conclusion, and I want only presented that the main result is creation of blockchain and how we can to use blockchain technology.
No, these are some applications of blockchain.
Yes.
These are some applications of blockchain, right? But what are the findings of your paper?
Okay, yeah. In order to ensure maximum efficiency of blockchain technology in CSI, it is necessary to develop infrastructure support for such innovation technology as availability of a high quality information base, development of appropriate policy and regulation. So, global trends in the introduction of blockchain technology in traditional production process and operation in most cases require an additional cost, but it does not ensure significant benefits in the short term, but in the long run it enable to create a transparent, decentralized, secure transaction process and thus reduce transaction costs. So it is a conclusion for our work.
Okay, thank you. Thank you.
Thank you, Alina.
Thank you.
Anybody else would like to ask the questions?
Okay, madam. I guess we have to call the next participant because we are running short of time.
Yeah. Thank you, Alina. Please stop sharing your screen.
Okay, thank you too for your invitation and possibility to take account in your conference.
I request participant ID 103 Sri Raksha.
Yes, ma'am. I'll be presenting on behalf of her.
Okay. Please share your screen. Start the presentation.
Okay, is my PPT visible?
Yes.
Okay, so the topic is all about analysis of deep learning methods for prediction of plant diseases. So when we talk about the introduction, agriculture being a backbone of India's economy, farmers face a huge loss every year due to the occurrence of diseases in the crop. The detection or the identification of plant diseases have been a challenging issue in the recent years. In plants, the symptoms are visible in stem, fruit, and leaves. Since leaves are the sensitive parts of the plant, the diseases or symptoms are observed here very fast or in a quicker form.
Tell me.
So plant leaves are considered.
सर अभी दो प्रेजेंटेशन रह गया है सर मैं आपको कॉल कर दूंगा I will call you.
So plant leaves are considered the primary route for detection of diseases.
Yeah.
In
Okay.
the early years, the main.
320 will yeah.
Sir, please mute yourself.
ठीक है सर.
Ashwini sir, please.
Okay, sir.
Okay. In the recent years, the main approach involved for identification is through the naked eye of experts. However, this requires a periodic and continuous observation. Therefore, the detection of leaf diseases through an automatic approach involving an image processing and a deep learning technique has been proven to provide a much better accuracy with a quicker result. So the problem statement, so since we are living in an era where agriculture has been a major issue nowadays, as said that plant leaves are most vulnerable to diseases due to the various factors like change in the climatic conditions or the attack of pests on the plants. The main aim is to develop or design an automatic detection of diseasing leaf at an early stage and a methodology for detecting the diseases in the leaf with the proper usage of a deep learning algorithm and an image processing technique. So the literature work here, according to the author Prasanna Monti, in the paper Deep Learning Plant Detection of Image Base, he has used 14 different species of unhealthy plant leaves and attained an accuracy of 96.35% using a method called as convolutional neural methods. Then, according to the author Malavika Rajanet, in the paper Artificial Neural Network Detection of Diseased Leaves, she has used an algorithm known as an ANN model and tried to attain an accuracy of 80%. In the paper by an Hari Balagan, detection of an unhealthy plant leaves using the texture features. Here they have used a GRB image, that is red, green, and black image as an input to detect the diseases and could not attain a good accuracy rate. Their accuracy rate was around 83%. 89%. So in the paper, Kulkarni proposed the early detection of diseases in plants. The paper was mainly based upon an ANN and a Gabler filter. And ANN is used for the classification, followed by an Gabler filter for the extraction of the features of the leaf, which gave a better results compared to the other papers with an accuracy rate up to 91%. The next paper by Josna Balkar used a CNN-based model again, which tried to with a different species of plant, which had a capability to attain a result of 92%. The next paper used a combination of CNN and GAN detection in plants by Emmanuel Kotz. The paper attained an accuracy rate of 85%. So in the proposed methodology by us, we are taking an input of a plant image as an input data set and have been applied into a pre-processing method. In the pre-processing method, the image is being resized and converted into an array. Then for the feature selection method, the data set is being split into the training data set and the testing data set. After that, all the images are resized and converted into an array. Finally, the classification uses an algorithm called as a DenseNet 1-to-1 algorithm, to which a disease can be classified, and you can predict if the leaf is an unhealthy or a healthy leaf based and attain an accuracy result. So this is the algorithm of our proposed system. First, initially, we are going to take a data set, and then we are going to do the data pre-processing. That is, we are going to do the visualization and the rescaling. Once visualization and rescaling is being done, we are going to process it for the feature selection. And then the next process is the application, applying of a suitable algorithm. So once the algorithm is being applied, a result will be generated based on the algorithm applied. So result and discussion, as we did a lot of literature survey and came across different types of papers proposed by different authors, this was a rough conclusion which we came across. These authors, using a different models, attained this accuracy like 96% or 80% or 91%. So the system which is being proposed by us, we have been estimated to attain an average value of 94 to 96% accuracy rate. So I would like to conclude by saying that human life is dependent on crop production, and that it would decrease in the country's economy if the crop production is being affected. The paper shows an overview done about the recent research in the plant disease recognition, and most of the deep learning technologies that are proposed has been shown a positive result and brought in the light of improvement with a future scope. Hence, there is a need for an automatic detection of diseases in plants at an early stage. Talking about the future work, we can implement it through a better and a more supervised algorithm, taking a large number of data sets and implementation, or taking a better clarity of an image on application of a more supervised algorithm. Thank you.
Okay, thank you, Harshita. Sir, please go on with the queries.
Yes, Harshita.
Yes, sir.
Which paper is the latest one that you followed for the literature review? From which year? Is it from 2020 or 2021?
Sir, the latest one was, I think 2020 was the one which we took as the latest paper, which was being proposed by Prasanna Mohanty, which attained an accuracy of around 96.35%, sir.
Actually, we are discussing in the month of March 2022, right? And I also worked in the same one paper that is based on the leaf and spike weed disease, and that is in 2021. And I followed the same approach, and the result was approximate 97.8. So how you can claim in 2022 that your results are best one?
Okay, sir, since we know...
I'm saying the title, just follow it. And the title of my paper was Leaf and Spike Weed Disease Detection and Classification Using an Improved Deep Convolution Architecture. You can follow. It is from 2021, Elsevier paper.
Okay. So since we know that there are a variety of papers that have been available on this topic, we have just gone through roughly about 10 to 15 papers since we couldn't go through all the latest
that is a suggestion. That is a suggestion. You should take in such cases.
That is a suggestion. Yes, sir.
Yeah. You should take the latest one.
Then,
you should take the latest one. Then you should compare. Otherwise, we can compare from 1981. And we can say like my findings are the best one.
Yes, sir. I hope Varshita, you might have noted all the points given by the session chairs.
Thank you.
Huh?
Yes, sir.
Yeah. You will implement all those points when you are doing your next paper, right?
Yes, sir. Sure.
Mm-hmm.
Yes, I request Sushma, paper ID 42. Sushma, can you hear me?
Sushma is not there, I guess.
Excuse me, sir.
Yes.
Yeah, sir. We have paper ID 159.
Yeah, you can proceed. Yeah.
Okay,
yes.
Okay.
You can proceed. You can proceed.
Thank you, sir.
Mm-hmm.
Yeah, hello.
Yes,
hello.
Yes, please go on.
Good afternoon. Good afternoon, everyone. Can I share the screen? Right?
Vineet, you share your screen first.
Yeah, please. Yeah, I'm sharing. Can all of you see the screen?
Yes.
Okay. Thank you.
Yeah, Vineet, make it in full mode. Yeah. All right. Great.
Thank you. So the title of this presentation is Life Prediction of Underwater Electroacoustic Sensors using Data-Driven Approach. And my name is Vineet. I am working in DRDO Young Scientist Laboratory for Smart Materials in Hyderabad. And my co-authors are Professor Pramod Sridharan and Pranavam from Amrita School of Engineering, Kerala. So as we all know that underwater electroacoustic sensors are commonly used in military and non-military applications, especially in sonars, where the sensor is used to catch the sound as well as to send the sound signals. Also, it is used in inspection of submarine pipelines for damage, then autonomous underwater vehicles, remote operated vehicles, and studies related to seismology and marine organisms. So the basic component in these electroacoustic sensors are piezoelectric materials, so which is a very common material. So this is actually a dielectric material, and this material is suitably encapsulated using some polymer like rubber to make it water-worthy. So generally what happens when in operation in sea, the sensors will absorb moisture. Also, due to the aging of this material, the performance of the sensor will degrade over time. So we are interested in studying the life prediction of these sensors in water. So this is the basic agenda of our presentation. So this author Ramesh et al. He has authored a paper in which he said that the sensitivity of these hydrophones at low frequencies are represented by this equation, where this sensitivity M is a function of capacitance and insulation resistance. As we know, insulation resistance is very important in underwater, and we can see when we plot this graph, we can see that the receiving sensitivity reduces drastically below a cutoff resistance. And now coming to this prognostics and health management, which is a very common buzzword, especially in the era of digital twin and Industry 4.0. So the prognostics is a process of estimating the estimating the time at which the component fails to perform its intended functionality. So basic aim is to find the remaining useful life of the component using the data obtained from the sensor. So we don't know exactly about the damage level of the sensor, but we can predict using the data collected from the sensors to check the futuristic performance. So here these prognostic approaches are divided into three: data-driven approach, a physics-based approach, and the combination of both, that is called the hybrid approach. So here we can see that from the previous data, we can forecast what the performance is going to be, and we know there is a failure threshold, that is a damage level of the sensor, beyond which the sensor will not perform at all. So that is marked the end of life of the sensor or any asset. Sorry. Yeah. So we have done the experiment using. We have put the sensor in a seawater bath and collected the capacitance and insulation resistance of the sensor over time in regular intervals. And we checked that the sensitivity, or the threshold value of the sensor, that is 48 mega ohm, is crossed when the time is like on the 93rd day, the failure is observed. So what we have done, we used a data-driven approach called LSTM RNN for forecasting the life. So we know that the regular RNN are, they are basically good in time sequence of data, but they have vanishing gradients. The gradient will become 0, which is not good for predicting the future. So this LSTM long short-term memory will have like it will collect all the previous memory, like a long memory, and it will forecast the future. So this is the basic architecture of LSTM. Then what we did is we have taken the data for the first 65 days and then put it into this LSTM algorithm, and we have made it to different batches. In the first 14 batch, we have checked the the next insulation resistance, that is the 15th day insulation resistance. Then we have taken data from 2nd day to 15th day. Then we have predicted the insulation resistance on the 16th day. Like that, time marching is done. Then this is how we have done the training. So in the training data, we have 52 such batches having 14 inputs, and we have one output, that is the target. Then we have done the training of the model, and we observed that the error after 50 epochs, the error of training and validation almost converges. So yeah. So this is the result. So up to this 65th day, we have taken the data for both. Actually, this is the actual end of life, and this red color plot is the predicted value. Then this portion is zoomed over here, so we can see that the sensor actually failed at the 93rd day. But using this method, we can see that it failed before 85th day. So there is an error of 9 days is observed. So which is very good, because in any working system, early warning is always good, because we can avoid any catastrophic failure in future. So this verifies that the LSTM RNN predictor is very good for forecasting such kind of cases. This comes to the conclusion. We have done the data-driven approach for life prediction of the sensor. Then the method the LSTM RNN could predict the early life of the sensor. Then what our future plan is to do the study with so many sensors in different atmospheric conditions, especially when the sensor is working and at different temperatures and pressure. We want to study how the sensors are going to behave, also with many sensors. And we also have time series forecasting with other algorithms like transformers and other things. So this in nutshell, we have done all these studies, and we are also planning to do many other studies in future. So this concludes our presentation. Thank you.
Vineet?
Thank you,
Yes,
Vinit. Sir,
yeah, thank
please,
you.
sir, carry on.
Yeah, thank you. Thank you. Nice presentation. Just tell me one thing. What are the parameters which you have considered while getting the data?
Okay. We can say here from the day 0 onwards, we started recording the capacitance and insulation resistance of the sensor.
It's okay. It's okay that on the day 0, day 1,
yes,
day 17, day 18, you are collecting the data. But what are the conditions, various conditions, like the temperature, the weather? Have you considered those parameters also?
No. The seasonality is not considered in this case.
Okay.
Yeah, but yeah, even seasonality can be checked in the sensors. In this case, sorry, in this algorithm.
Because if the temperature is too low or if the temperature is too high, that might be the value will be different from whatever values you are getting right now.
Right. Yeah, yes, sir. That's what I am going to do in the future under different conditions, and I will also incorporate the seasonality.
Okay. Thank you.
Thanks, sir.
Thank you, sir. Anybody else would like to ask the questions? Okay, I'll call upon paper ID 164, Yogesh Kumar.
Okay, thank you, everyone.
Yes, ma'am.
Khushbu will represent on behalf of
Okay,
Yogesh.
Khushbu, please carry on with the screen sharing.
Can all of you see my screen?
No, please share it again.
You have to click on share screen, the entire screen you have to share.
Ashwin, one more presentation, last presentation.
So this is last presentation, sir.
Okay.
Now it is visible?
Yes, now visible.
Okay. Thank you so much.
Sorry.
A very good afternoon to all of you. I am Khushbu Saxena, research scholar of Banasthali Vidyapith, Nivai, Rajasthan. Today, I am here to present my research paper, that is underwater image restoration and enhancement based on machine learning and deep learning algorithms. All we know that digital image processing domain is growing day by day with various technologies like artificial intelligence and machine learning. Underwater image processing is considered as a crucial task in image processing industry due to the scattering and attenuation of light into water, so that underwater image is usually appear with color distortion, blur detail, and low contrast. For this, to address this problem, machine learning and deep learning play a very important role to optimize better restoration rather than a conventional approaches. In our survey, we found various problems, that is presence of sea ice and floating particle around cooling the camera, so that backward and forward scattering of light energy, which is a cause of low contrast and hazy image appearance. Blue color penetrate deeper due to the shortest visible wavelength, so that the blue color underwater images get affected. And another problem is underwater images are getting darker as deepness increases. This is the literature survey of our work. In this literature survey, I refer 7 to 8 research papers. First author G. Ram Kumar proposed a method, effectual deep learning convolution neural network technique, which gave the result that uses SVM and deep CNN method. In SVM, accuracy was 86.2% and deep CNN accuracy was 95.12%. Similarly, various methods based on convolution neural network and machine learning proposed, and their findings are listed here. In our methodology, here I am proposing a hybrid method which is related to color correction and contrast enhancement. Firstly, we are using Kaggle dataset for retrieve hazy images. This is a source of our input, and firstly we are applying color correction method, which is the aim to correct the color, and simultaneously we are using contrast enhancement method, which is the aim to adjust the relative brightness and darkness of object to improve their visibility. After that, we are using image denoising and dark channel prior algorithm. Motive of image denoising method is to advance procedure of improvement of image to remove noises. Similarly, dark channel prior method is used to significant dehazzing method based upon the key features of his images. After that, for deep learning, we are using convolution neural network. After that, we have enhanced images. This is a proposed research paper. So our expected result will be It will be the generate a haze-free images by compute the complexity of haze. After that, I will be able to report the problem of inferent invisibility. I will be able to articulate a hybrid method to enhance and enhancement and restoration of his images. After that, we will be able to expand the quality of an image to compact with low contrast and equate the usefulness of suggested algorithm with conventional methods. For conclusion, after this proposed methodology, underwater image processing has various remarkable advances in enhancing and restoring images, but restoring the visual quality of underwater images remains a great challenge. Thank you, sir. Hello.
Yeah. Thank you, Kushbu. I request the session chairs to please go on with the queries.
Yeah, Kushbu, good presentation. Just tell me, what is your base paper? And
So this is sir, in slide 4th,
yeah.
G. Ram Kumar is our base paper.
What is the publishing year of this paper?
2021.
2021. Okay. Okay. Good.
Thank you.
Kushbu,
Yes, sir.
what are the problems we are finding from base paper?
Sir, in this paper, we are improving the quality of SSIM and BSNR. In this paper, SVM accuracy is 86.2%, and right now I am using a hybrid method based on SVM and deep CNN method, and we found that our accuracy is 91%.
Have we implemented till now?
Yes, sir.
Okay.
Now it is implemented.
Okay.
Thank you, sir. Anybody else? Okay, just a moment. I request all the participants to please stay there. We have a small technical glitch here. We'll be right back in 2 minutes.
Swati ma'am, can you hear me?
Yes, sir. Yes, sir.
Yeah, actually, one more parallel session is last presentation going on.
Okay, okay.
Then we will start our valedictory session.
Done, sir. Okay.
Yeah. हाँ सर हो गया, चल रहा है। हाँ अच्छा ठीक है, जल्दी बंद करिए सर। सबको बोलिएगा मेन रूम में आ जाए, मेन रूम में ऑटोमेटिकली आ जाएंगे। ठीक है ओके। Swati ma'am, it is about to finish. Only 1 minute left out.
Done, sir. Okay.
VC sir has joined the meeting.
Okay, sir.
Principal sir also there.
Okay.
So we are going to start our valedictory session for this conference.
Okay, sir. Let me. Okay.
Yeah, you can switch on your camera, madam.
Okay, sir.
Sir, Janan sir. Yeah, Ashwin.
Sir, welcome, sir.
Yeah, good afternoon.
Good afternoon, sir. Firstly, I would like to welcome our respected Vice Chairman, sir, Sridhar Reddy, sir, and our Principal, sir, Dr. Sri Sai Satyanarayana Reddy, sir, to the conference valedictory function. And firstly, I would like to thank all the session chairs of session 7 as well as 8, Dr. Anupam Singh, Dr. Goose Muhammad, and Dr. Professor Pavan Verma, as well as Uma Maheshwari ma'am, Shankar Ponnapalli sir, Nanda Kumar sir, and Vikas Goyal sir for gracing the sessions today. And I would like to thank all the authors for presenting their papers. Now, I request our General Chair, Ashwani Kumar sir, to please start the valedictory ceremony.
Thank you, madam. Am I audible?
Yes, sir.
Yeah. A very good evening to all the dignitaries, keynote speakers, session chairs, authors, faculty member of Sreyas Institute, students, ladies and gentlemen. As we come to close our valedictory ceremony, I take the privilege to give vote of thanks today. On behalf of CSE AI&ML department, I would like to thank our management and our Vice Chairman, sir, of Sridhar Reddy, sir, our Principal, sir, Director Science Satyanarayana Reddy, sir, who is leading the institute from the front, Dr. V. Beekcham, convener of the conference ICAIDS-2022, our TPC chair, Professor Pradeep Kumar Gupta and Professor Mayank Singh, who supported me to conduct this international conference from last 2 months. This last 2 days, we had 5 keynote talks from different speakers across the globe. All the talks were very informative and impactful. Keynote speaker had given deep insights into several issues of artificial intelligence and data science. And we were very fortunate enough to have very eminent speakers for delivering these keynotes. I'm sure that these talks will be very much useful and will help us to understanding the emerging computing techniques and will open a new research areas for the researchers. ICAIDS-2022 provide the researchers a great platform so that all the author has interacted, they have shared and discussed the new research problems which are right now going on. I'm extremely grateful and thankful to all the members of various committee of International Conference of Artificial Intelligence and Data Science 2022, reviewers, technical program committee chairs, technical program committee members, organizing chairs, Nabi sir, Jairam sir, Achut Rao sir, Biksham sir, Shankar Ponpalli sir, Padma Joshi madam, for their support and making this event a grand success. I would like to invite our Vice Chairman sir to speak few words on this closing ceremony of this conference, ICAIDS-2022. Over to you, Hriday sir.
All right. Thank you, Ashwin Kumar sir. And first of all, I would like to thank you for organizing such a wonderful event. I think it has been a grand success. We got several papers from various different countries and as well as various different colleges in India as well. And I think this conference will definitely be helpful to our staff in guiding our students, because especially we have an intake of around 120 in AI artificial intelligence and another 120 intake in data science. So all these latest trends and latest technology advancements or whatever it is will definitely help our staff, and not only our staff and all the participants, those who have submitted papers in our conference, will definitely help them in improving their knowledge and broaden their skill. And like to thank all the keynote speakers and all the department staff, those who have wonderfully organized the event. So I'd like to thank our principal sir, our HOD sir, Ashwin sir, and Swati madam, and all the coordinators. Don't know the exact names, but it was a wonderful event, two-day event, and I'd like to thank all the staff, those who have published their papers in the conference. And good sir, and we'll plan to conduct more events in the future. And, thank you for organizing such a great event. Thank you.
Thank you very much, sir, on your insight thoughts. Now, I would like to invite our patron and program chair of ICAIDS 2022, Dr. Sai Satyanarayana Reddy, sir, to speak few words on this occasion.
Yeah, thank you. Can you hear me?
Yes, sir, we can hear you.
So glitter ends, but glow remains. So now we are concluding this program, but the glow still is there. Really wonderful sessions. I've been attending almost 3 or 4 keynote addresses, and really I appreciate all the 5 keynote addresses by maybe Jupeng Jessing and maybe John DeBoyle and Muhammad Usman and Pradeep Kumar Gupta. So all these keynote and Ishtak Fisher from Jindal University, Maribor. So all these keynote addresses are really astonishing and really given a lot of insights about the AI/ML and data science in fact. And all the participants, in fact, they really presented well. Some papers are very good and thought-provoking, and maybe they are talking about some cutting-edge technologies and really good. And there's definitely a takeaway to all the participants and the listeners who are actually gone through these 2 days of international conference in the AML and data science. So I really appreciate the efforts put by Dr. Ashwin, who is the man behind this program, and also Dr. Biksham sir and Swati madam, and especially the person who is given all the rights to us is our dynamic vice chairman sir, Uday Reddy sir. I really thank him because he is the man who always motivates this type of programs in the college on regular basis. And also all the participants and the people from Springer and from JP University and friends of Ashwin and all the members who participate in this program. I really thank one and all, and thank you very much for giving this opportunity. Thank you. Wish you all the best.
Thank you very much, sir. Now I would like to call any participant if he would like to speak for the feedback of this 2 days international conference, that is International Conference of Artificial Intelligence and Data Science 2022. We will be very happy to hear from you. Any participants who want to speak or want to give some suggestions? Okay, sir. I think nobody want to speak here. So I am just closing the session right now. So on this note, let's conclude a remarkable, memorable and knowledgeable valedictory session. Thank you very much. And all the participants and author, I look forward to meet you again in the second series of this conference, that is ICAIDS-2023 at Sreyas Institute. So thank you very much.
Excellent.
Thank you, sir.
Thank you. Wish you all the best.
Thank you, sir.
Thank you, team.
Thank you, sir. Signing off, sir. Signing off. Thank you. Vikram, sir. Sir, by mistake.